which the key terms which I'm going to tell you, because that is going to help you because understanding the software later on as well. Because the thing is, the steps which I am going to tell you today is actually a 5-day course. So complete 5-day course. So I am going to do it in a rush, in a speedy way. So there may be some points which you may have to refer back again. Uh, so when I will take you through some of the, so I'll take you through some of the key steps or the key terms which you should remember, because what will happen then? What will happen then when you will be uh, communicating? Say you are communicating with me for understanding some of the parts in the software which you have not understood, or you want some guidance. Then when I'll say for example, when I say window, you should know what window means. And if I say control bar, then what does a control bar means? So these things you should remember, and these are pretty much same for any softwares. So if you can understand what a menu bar is, what a control bar is, what a status bar is, then you can, in any software, you can mention, or when you are taking a guidance from someone, you can mention, you you can mention that I'm going to a menu bar and I'm seeing this in menu bar, this uh, tab I am not understanding. So this will help you in communicating in a better way. Okay. So I'll share my screen. So tell me if it is visible or not. Is it visible?
Yes, sir, it is visible.
So which screen you are seeing? Is it the screen where all your parties,
Teams.
all the,
Yes, sir.
okay,
Yes, sir.
right, fine. So that's right, that's perfect. Okay. Okay, I'll quickly jump to this window. Now you're seeing the Datamine Studio.
Yes, sir.
Yes. Okay, fine. Now this is the page which everyone is come
Hello, sir.
page. And if you go through the steps, I mean, which part is said what? So this basically
Dhruv,
this
sir,
complete. Yes,
can you hear me?
yes, I can hear
Sir,
you.
your voice is very feeble and it is breaking also. Can you speak a little louder?
Okay, so what I'll do in that case, I'll switch off my microphone and let me change my microphone and check. Okay, give me 2 minutes then.
Okay.
Priyanka or Sripali, you can add Vijay. Hello? प्रियंका विजय को ऐड कर लो
Am I audible now?
Yes, sir.
Hello.
Yes, sir.
Hello. Is this audible now? Really?
Yes, sir.
Yes, sir.
Clear, Abby?
Yes, sir. Clear.
Okay. So, so I'll start with the window, Studio RM window, and then slowly we will take it ahead. Okay. So about this window, so this is this part, this start section is called window. And when you talk about this complete software, so upper portion, which is this, where you can see home, data, sample analysis, this area is called menu bar. So whenever I'm talking about a go to menu bar or is there in menu bar, so this is the menu bar where there is home, data, spatial analysis, sample analysis, structure, model, estimate, report, format, edit, these things. Okay. And similarly, this part, this section, where there is this customization, project files, whole files, the loaded data section, or even this area, this sheet, all these areas are called control bars. Okay. Because you are controlling your execution or your software parts through these sections. So these areas are called control bars. Even this prompt section, this is also our control bars or prompt bars, command bar. So in prompt bars, there is one command, output, and desurvey. So when you do a desurvey or validated reload, the desurvey report comes here in this prompt bar. When there is something you are running as an output, say estimation or all, so those outputs will come here, output of those estimations. When you run a command, the result of that command or how the process command is running on, this comes in this prompt bar. So this is called a prompt bar. These
Dhruv
are,
sir, your voice
yes,
is still breaking. Hello?
voice is breaking maybe because of internet.
Yes, sir.
So
Yes,
that
sir. I think actually I know to confirm from everyone that Dhruv sir's voice is clear from all of your side, or it's something
It
going
is
issues with my.
it is clear from my end.
Side. Same. It is clear.
Yeah, it's clear from also my side.
So Shipali, you have to connect to another internet in that case. Maybe because there is windy today also, no? Outside.
Okay, then again I'm saying.
Sripali, please
Should I?
add Vijay.
Shipali, add Vijay. Vijay is waiting outside.
We should have network issue. I don't know. Sir, it's not clear actually from our side.
Am I audible now, Shipali?
Sir,
Am I
Vijay sir is
audible?
also trying to. Huh?
Am I audible?
Yes, sir.
Now, yes, sir. Now you are audible.
So maybe the line is breaking. That may be reason. So also we are recording, so it's fine. Uh, I will repeat if you miss anything. You can
Yes,
prompt
sir.
me.
But
I'll
when
repeat
you are
again.
continuously speaking, then it's breaking. The voice is breaking.
So what can be done in that case?
It's breaking. Yes,
Okay.
sir.
Okay. Let me continue, Hannah, and then we'll see. So this is control bar and this is the prompt bar section. Now coming at the bottom section, bottom area, where you can see right now it is mentioning as for help, press F1. And at the right hand side, right hand corner side, you can see there is written command, cap, nonstop. So this bar is called status bar. So any command you run, that will get reflected in this. and the status of those commands, if it is running or it has stopped or it is still in progress, those status bar comes in here. Here only in this section somewhere here, you will see the coordinates of the, when you will move the cursor in the window, you will see the coordinates also in this section in the status bar. So this is called status bar. So am I clear on this part, which is window, which is control bar, which is menu bar, and which is status bar?
Yes, sir.
Yes, sir.
Okay. So I have I have some slides. It's a pretty old slides which I was using for training in from Studio 3. So I'll just show you that. I'll skip some of the parts because that is not relevant, but the parts which are relevant, I'll take you to that, and then I'll again jump into the software. So this is what I was talking about. So this is the start window, and here the project starts, and and if you see the menu bar also, the menu bar is right now it is little bit here you can see it is little bit old, but the newer version has little bit some different colors and all. But this process is same. You have to go to the you can go to the file and you can open any recent project, or that is the same thing gets reflected in the start window as in these sections with the recent projects. This is the area where when you start the project, you will find this window as a project window where you can we will see the name of the project and the location of the project and all. And I'll skip this. Yeah, that is what I was saying, the interface. So there is in terms of interface, there are this start page, design, and then the file section, design, visualizer, VR, plot window. So these are all windows which are there. And then there is control bars and other windows as well. And there is a toolbar. Toolbar I missed. I'll show you again. Toolbar is the area where you can click on those small tools which are there. These are the short commands for, or the quick access for the menu bars which is available. The toolbar also has those icons through which you can also go through. And then the menu bar is there. So this is the title bar. Okay. So the title bar comes at the top of the window, which is called the title bar, where you can see the name of the project. Then comes the menu bar. This is the section where the menu bar comes in. So this is called the menu bar. And then comes the tools. So tools, right now, this is not here. Right now in Studio RM, it comes in the right-hand side. And also you can adjust where you want to keep it. You can keep it at the top, or you can keep it at the right-hand side or at the bottom. But these are the tools which are called the toolbar sections. Control bar, as I mentioned, the side windows are called control bars. This is again, these are another additional control bars. This is the main window. Now in main window, there are multiple windows like start page, design page is right now not there in Studio RM, but otherwise visualizer is also, I think it's not there, but there is 3D window right now. There is plot window is there, table window is there, log window is there. And this is the control bar, another control bar for viewing where the prompt happens, the command prompt, output prompt, and the discovery prompt. And then the command bar where you put the commands. So say, for example, when you desurvey, you put host 3D or any other commands, batch commands, which are called basically batch commands. So batch commands are put in command bar. So this is the area which is called as command bar. And finally comes the status bar where you can see the status of your program. So what stage you are in. If you have run some process, then the status of that process will come here, as well as the coordinates of the process is reflected here, and then the command which you are using. Say, for example, you are using some short commands, or you're creating a new string and you use ns. The short command of that the particular command gets reflected. Short key of that particular command gets reflected here. Now, in coming to this window, this section, this central part. So there are 9 windows mentioned, but design window has become obsolete right now. It was there in Studio 3, but you can use it in Studio RM as well. by going to the legacy section and you can add design window. Otherwise, and visual, same goes for the visualizer. Now in between out combining these two, the new window which has come up in Studio RM, which is called a 3D window. And then there is plot window, logs, tables, reports, VR, start, and files. So this I'm skipping. This I'll mention this part, status bar, because this is a small section but very important section of the software. So what section within status bar there are multiple sections. Now if you see, this is the message area where whatever command you are running, the message comes here. This is the progress bar. हेलो, कहाँ तक बोला मैंने? हाउ मच I when I cut through?
सर आप
पीपीटी में डिस्प्ले कर चुका था,
नहीं सर डिस्प्ले कर रहे थे सर आप।
तभी चला गया था क्या? तो
Yes,
मैं
sir.
ऐसे हवा में बातें कर रहा था। सही है, मेरे को पता भी
तो
नहीं
मेन्यू बार एक्सप्लेन कर रहे थे आप।
था। ओके, मेन्यू बार। ये सेक्शन दिखा था तुम लोगों ने, कंपोनेंट्स।
सर स्क्रीन अभी विजिबल नहीं है सर।
ओके, ये कंपोनेंट सेक्शन देख रहे थे कि स्लाइड्स, ये स्लाइड्स दिखे थे क्या?
नहीं सर।
Okay, so I'll start from the beginning in that case. So starting a project, this is the start window, and let me know whenever you feel like you give me a nod in between so that I can understand ki everyone is there, because I can't see while presenting, I can't see if I'm online or not. Okay,
Okay sir.
Good screen.
screen is visible. Okay, so this is the start page. So in terms of start page, what it is written here, you can see. So when you open your start window, this is the area which will show you your recent projects, and you can go also through the menu bar. So this is what it is shown, but the window is little old because this is from the Studio 3, not from Studio RM. But more or less the menus and the items are almost the same. Now I'll quickly take you through the next part. I'll skip these things because I'll take you manually through the software. What I want to explain here is about these bars. So this component section is important because this is going to show you all the items or all the sections that is there in the software. First section which is there is title bar. Okay, am I audible now?
Yes sir, you are.
Okay, okay. So this title bar reflects what is the project name or what is the project in which you are working. Then comes the menu bar, which is having all those file, edit, view, and all those sections. And then comes this toolbar. Now toolbar is placed here, but you can change the position of the toolbar by moving. If you see in this new Studio RM, the toolbar comes on the right hand side, but that can also be changed. The position can be changed. But these tools, wherever these tools comes in, this area is called toolbars. So whenever I mention toolbar, that means I'm mentioning about these areas. Then this is called control bars. So these are the control bars, which is the control bars mainly are the project file, the loaded data sheets, as well as there are other areas like the data properties and then compositor and then property. So all these sections are the control bars. This part is called the main window, where there are multiple main windows. Design and this visualizer window is not present in Studio RM because that has been combined together as 3D window. And then other than that, there is plot, there is table, then there is log, and then there is another set of control bars which are also sometimes called as prompt bars, because here you can see all the outputs and the whatever commands you are running, the reflection of those commands or status of those commands can be seen here. So there are three parts in this section. One is command prompt, another is output, and the third one is the survey report. Now, then comes this command bar where you put your commands. So this area is called the command bar, where, for example, when you are validating a hole, then you run holes 3D. So holes 3D is run here in this section. So this is one area which this is also called as sometimes called as batch command. Holes 3D or these commands are called as batch commands as well, which is written in the command bar section. Then finally comes the status bar, which is the area where you can see the status of the projects. Now, when I talk about the status of the projects, that means there are multiple sections where you can see. One section is showing your status of the project. There is another section of which is showing the cursor point, and there is another additional section which is showing whatever commands you're running, the short key, quick key of those commands. Is it clear? Audible? I'm still online?
Yes, sir.
Okay. Sorry. Okay. Now, in terms of windows, as I mentioned, this design and visualizer window has combined into a 3D window. And there are other windows like plots, logs, tables, reports. So whenever someone says plot window, that means that there is a window which is called plot, and here in this area you can say you have to take some prints of in proper sections in proper scale. Then you have to use this plot window. Now, say you want to create log profiles or logs of your drilling data, so you have to go to the log section, log window, and then you can create logs of the drilling information. Table window is to display the tables with files of your input and the output files. Whatever you are importing, those table inputs can be visible. It's a similar sort of similar like Excel columns and rows, but it is in a different window, which is called a table window. Report is the section where you can see the reports of your outputs. Like you ran, say you created a model and you run the estimate. You want to know the tonnage and grade or estimates of the model, then that will be visible in the report section. VR is the visualizer window. So I think this is also not there right now because that has mixed with the 3D window right in Studio RM. So a start window, as I mentioned, this is the first window of the area where you can see your recent projects and you can create a new project in this area. Files section is the area window where you can see the files of a particular particular file, all the files that are there. I mean, say you have imported caller file, litho file, as well as you may have imported some point file, or you may have imported some vector files. So all those files can be also visible in the file folder. This is about main window. I'm skipping it. Status bar. This is very much important. The status bar here, as I mentioned earlier, also there are three sections mainly, which is first is the message area where you can see the message of your running commands, and then there is this progress bar, which is actually show the progress of your running command. Mouse position is the area wherever you are in the window with your mouse, that will reflect the mouse key or the coordinates of that area. If you double click this area, this window opens up, which also shows the mouse position. Here you can log the coordinates also. Say you want to go to Z coordinate, a particular Z coordinate, then you can log the Z coordinate, type that coordinate, and can enter, click on the window, and then it will go to that particular Z. So this way, in X or Y also, you can log the coordinates and can go to particular area. Then there is the status area where you can see what is caps lock, num, scroll, and read sections are there to show if caps lock, what is the status of this caps lock, if it's on or off, number keys on or off, scroll keys on or off these sections. Another is quick key command. So quick key command is something like, say for example, you're creating a new string. You can go to menu bar and come to new string. You can go to toolbar and also click on the new string. And also you can use a shortkey command, which is ns. So these are the multiple methods through which you can queue. So when you are doing it through menu bar, say you go to menu bar and go to a new string, then directly in this quick key command, it will reflect the quick key or short key of that particular command saying ns new string. So that way you can know that what is the quick key command for that particular menu bar command which you are using, if that has a quick key command. Otherwise, it will not show here. Everything okay till now? Hello?
Yes, sir.
Okay. So बीच में करते रहो क्योंकि मुझे दिख नहीं रहा इसलिए. When I'll be in the window, I'll presentation mode से बाहर आ जाऊंगा, then I can see if I'm online or not. ठीक है. So control bars के बारे में बता दिया. I have already told about the control bars, so that's fine. So you know about these things, project files, loaded data. So this is the project file. So project file section is what? Project file section is all the project files, whatever project files are there in your, hello, am I audible?
Yes, sir, you are audible.
Yeah, यहाँ पे light चली गई. So I think I have to skip to my main screen. So I have to remove my additional screen. यार ये प्रॉब्लम है, अपने घर से करना. Okay, share screen, that's fine. So I hope now screen is visible again. Right? Screen is visible?
No, sir, it's
No,
not
sir.
visible.
Oh. Is it visible now?
No, sir.
Visible? No, not yet.
No, sir.
What is happening? One sec. Let me leave and come back again. Huh? Add me again. Hello, am I audible now?
Yes, sir. Yes, sir, you are audible.
Okay. मेरा स्क्रीन पता नहीं क्यों शेयर नहीं हो रहा. Trying multiple times.
ब्लैंक ही आ रहा है सर स्क्रीन पे.
हाँ वही. I don't know why.
सर हम लोग का हो रहा है स्क्रीन शेयर.
मेरा नहीं हो रहा ना. मेरे कंप्यूटर में पता नहीं लाइट जाने के बाद वो कनेक्ट था उसमें ना HDMI में कनेक्ट था तो उसकी वजह से हो सकता है इसका. क्योंकि मैं शेयर कर रहा हूँ ये निकल आ रहा है शेयर से. यहाँ शो कर रहा है कि शेयरिंग स्टॉप शेयरिंग का ऑप्शन आ रहा है बट स्क्रीन विजिबल नहीं. अभी दिख रहा है?
यस सर.
ओके. So I have covered the status bar section, right? So this is the status bar section. This window is visible, right? To you all.
Yes sir.
So let us come to the main point of using a Datamine software. So for what purpose we use it? Actually to get a 3D display of the drill data. Mainly we are the actual generation of a 3D modeling software is basically for viewing the drilling data sets and creating sensible outputs from these drilling data sets. So the basic files which are required for importing any drilling data sets are these files, which is called caller file, survey file, assay, and geology. You can name the assay file as any other file or geology file as any other by any other names, but ultimately in short form you can call them as a sample file as well, because these are carrying the samples of details of the drilling data. So sample details, in a way, it can be a numerical detail of assay values. It can be a categorical detail or alpha detail of the geology. So, but these two files are called as sample files. Most critical files out of the sample file out are important, but the most critical file is caller file and survey file. Caller file is always called as caller file because that, as the name suggests, it gives you the basic coordinates of the drilling data. So the where from the drill hole started, that location is given in the caller file. And these are the four files which are shown in red are important and critical files for Datamine, which is BHID, X color, Y color, and Z color. And remember that this has to be in this format only, be it in this format, in this particularly this should be the name of the header of the headers, as well as all these should be in capital as well. So these are the three things which you have to remember, that for a caller file, BHID, X color, Y color, Z color is important and has to be in this manner only, as well as the name is always going to be BHID, X color, Y color, Z color, because that is the way the Datamine understands them as XYZ files. And third thing is all these files, all these headers should be in capital. If it is in small in and not are not in capital letters, then what will happen? It will not recognize the files or the headers. So that is very much important. Similarly, depth you can add or you cannot. That depends. If you don't add, it will not add the depth, but it will still run the file. It will still run the caller location file. Then comes the survey file. Here also the critical thing is every header should be in capital letters, and this is the sequence of that survey file, which will start with bhid. At means the depth at which the survey is taken, and then the BRG, which is for bearing or azimuth, and then the dip of the both drill direction. So the dip is actually the angle at which the drilling is done. So this is again a critical file. If you don't put a survey file in your drilling data in your software, then it will consider that all those drilling as vertical holes, and it will plot as vertical drill holes. So it doesn't mean that if you don't put any survey file, the drill hole data will not uh, validate or will not run. It will run, but it will plot as vertical holes, not as the directed holes or dipping holes as you mentioned in the survey file. So so this is again one of the important file. But if you don't put this file, then also the software can run. Then comes the sample files. Out of these two sample files, there should be at least one sample file to run the drill hole validation. So one is assay file, which is carrying all the which is carrying BHID from to length and the sample details. So assay values of, say, if it is iron, then Fe value, then if it is zinc, then the zinc value, lead value. Similar ways, all the assay values will be there. Now, particularly for these assay values, these can be in caps or may not be in caps. That's fine. But for these key fields like BHID from to length, these should be in capital letters. Now, geology, similarly, BHID from to and length should be in capital letters, and then the rock code and the description, which can be in small or caps, or which may not. If it is not there, then also it will run. Okay. Fine. Now I'll come directly to the software. Now the software window is visible.
Yes, sir.
Yes, sir. It's
Okay.
visible.
Now I think you all have have get the training data file which Priyanka has shared. So whosoever is, so everyone have this software, or because I think it will be good if you also practice it while I'm doing it. You can also do it. I'll give you some time in between also to run some of the error files and some of the validation tools, because that is important. So everyone has the software or not? है क्या सबके पास? बोलना पड़ेगा.
Yes, sir. Yes, sir.
सर
I
मेरे
have.
पास
अच्छा, किसके पास नहीं है?
सर आकाश.
कॉन्टेक्ट प्रियंका.
ओके सर.
प्रियंका के पास सब सॉल्यूशंस रहता है.
हाँ सर.
हाँ, लेकिन ये
Yes,
ऑफ
sir.
रिकॉर्ड है. ऑफ द रिकॉर्ड है ये.
Yes,
ठीक
sir.
है. ओके. Now coming to back to the software part. So मैंने भी what I have done, I have copied this training data here in this section, in this PC, Windows C database, DM tutorials, training. I have created a folder called training. So you also all can do, when you install the software, you will see that in PC, in C drive, there will be a folder called database. Within that database, there will be a folder called DM tutorials. So that is a default folder which creates whenever you create a Datamine software, whenever you install a Datamine software. Now within that DM tutorials, these are the files which will be always there, data and project. But I think project will not be, yeah, project will also be there and data will be also there. So what I did, I created another folder called training. You all also can do, you can create another folder called training, and you can keep that training data here. So I did the same thing. I'll extract this training file. So there is an Excel file which is within this training data. So I'll copy it and bring it outside within the main training folder and paste it. Now I have this training data. So I'll open it first and see what are the information available in that training data. If you can see, there is caller, essay, survey, and veto. Okay. All the basic files which is required, like caller file, essay file, survey file, and litho file is there. Now, if I go through the caller file, I can see there is this PHID, X caller, Y caller, Z caller, and depth all in capital letters. So that the file is fine for me. A preliminary validation looks in preliminary validation, it looks like the file is okay in terms of caller. Okay.
Yes, sir.
Then I'll go to the next Excel file, which is next sheet, which is essay file, which is there in as essay file, but the main file should be survey. So I can, if I want, I can check the survey file first also. So I'll go to the survey file and check it is PHID add peering dip. Dip one is there because the reason here dip one is there because if you have seen in the caller section, this is the X caller, Y caller are in some numbers which are not UTM, or neither it is a degree decimal. So basically you can see these are in local coordinates. Okay. So this file is completely in local coordinates and we'll keep it as local coordinates and do. Now, why this file is kept as local coordinate? The reason is the main reason is because this deposit is at an 45-degree angle to the geographical north. And while mining, it is difficult to mine or plan such areas where it is exactly 45-degree or because or you have to move your machineries or you have to keep the directions and do the planning properly, because earlier there was no rotated model C and if at all there is rotated model now also, but rotated model scenarios become a little complex. So the main the easiest thing which is done during the mining process is to convert the coordinate system into a local coordinate system and align the ore body strike with the strike of the align it with the northing of local northing of the area. So 45. So here what they did, I think I can show you in a diagram that will be more better. So let me check. I have Word. Board. I don't have. Let me check if I paint is. So what I was saying, say the deposit is mainly like this. Okay, the paint window is visible.
Yes, sir.
Okay, and geographical north is somewhere like this and this. So this is northing and this is easting, right? This is north. Now, because the ore body is like this, during mining process, it becomes a little bit difficult. So that's why what generally is done is the model is the coordinate system gets rotated aligning to this direction. So your north direction changes by this angle and gets aligned with this direction. So this is the northing local north, and that's how it becomes your local north. And the perpendicular to this strike becomes your local easting.
Okay.
Okay.
Yes, sir.
So that is how it is kept. Now, if you can see here in this system also in X color, you can see some minus values as well, right? Minus values means it is not in the east, it is in the west. So what is happening in this coordinate system is the 0, 0, the local 0, 0 is kept somewhere in between. So, okay, so this may be your 0, 0. So what then becomes this if you go towards the east section, it will become plus any section, plus 100, plus 10, plus 20, plus 50, plus 100, whatever section distance, depending on the section distance. And if you go west of the 0, 0, it will become minus.
Okay.
Okay, so this is your x. Minus 100, 0, plus 100. This is your x. What is not parallel to the strike? These are your not thing. Now this will also become plus minus. How? From 0, if it goes towards north, this will become your plus 100. And if you go towards east, southern part of from the local 0, 0, this will become your minus 100. Irrespective of the geographical coordinates, these are the local coordinate. This is the local coordinate system, what I'm explaining to you for this particular area. Understood?
Yes.
Any confusion? Anyone? No? Okay. Now for this particular diagram, which I have shown you, if I have to mention, because I'm saying that this angle is my 45 degree for reference here, only for reference. Okay. I'm not saying that this particular project is also in 45 degree, but I'm saying for this particular diagram, say this angle is 45 degree. So from geographical north to the local north direction is 45 degree. Now, if I have to mention the coordinate system here, so what I will say, my geographical north nice music. My geographical north is 45 degree, right? 45 degree to what? 45 degree
To east.
to east. And that is your
Local north.
Local north. Right, and accordingly the perpendicular is your easting and westing. So that is the way where you have to understand if the system is in local. So you also have to know that what is the conversion. Now, second point which you should know, sometimes it is not given, but is required, because if you want to convert it into UTM coordinates again, or you want to know geographically where it is positioned, the another important thing which you should always know is what is the coordinate of this local 0, 0 in UTM or in degree minute seconds. In geographical conditions, what is the coordinate of this 0, 0 local 0, 0? So that should be always mentioned, or if it is not mentioned, you can ask whosoever is giving you the data. If it is in local coordinate, do they know the conversion of first the conversion angle, direction, and as well as the particular 0, 0 coordinate in the geographical north. So for example, if just for an example, I'm saying, say this becomes here my local north, which is 0, the geographical or the UTM north is say 265,000. 1 2 3 4 5 6 0 0 0 0 1 2 3 4 5 6 7. Yeah. So UTM north is 265,000, and local easting, which is again 0, will become in UTM easting say 4 5 0 0 0 1 2 3 4 5 0. Okay. So this is just an example I'm saying. So you should know these things. Then what will happen? You can reorient the coordinate system into the UTM, and you can get get again back into the local. If you know the angle, so this is one thing. And the third information which you will be requiring is this, that what is the direction of rotation angle of from geographical north to the local north. So that is these three informations are required. Then you can clearly uh, you can convert or a local into UTM and UTM into local. And for example, you have a UTM coordinate system. You have created a model in UTM coordinate system, but the client or the mining team, or when you was actually starting a mine, then you have to prepare a grid system parallel to the ore body. So in that way, you have to use these informations. You have to create a local not a local 00, and you should be knowing that UTM coordinate of that. Then you should give a rotation angle to align the geographical north with the strike of the ore body, and then you will have your local coordinate system. And this is very critical when you have created your resource model and you are just you're just in discussions of opening a new mine. The coordinate system conversion of this coordinate system into local becomes critical, because that will help the mining engineers to prepare proper blocks for mining. Otherwise, what will happen? The block model will become angular, and the planning becomes a little bit difficult, because when they have to create the drives and the benches and all, that will become little bit difficult for them. Not for the open pit, but for the underground, it becomes very much difficult, because you have to create drives, ore drives and waste drives, and that will not get aligned with the ore body if it is at an angle. Every time the coordinate is changing, so that becomes difficult. Okay, so coming back to the file. So after the survey file, there is assay file, which is BHID from 2, and here there is lead and zinc. PB is for lead and Zn is for zinc values. Okay, and then there is lithological information, which is having one rock code for all. Now I'll mention the codes. You can write it somewhere. DO is for dolomite.
Okay.
The key rocks I will mention because there are a lot of codes. And then this is biotite cyst, that is fine. CBS is actually calc biotite cyst.
Okay.
Okay, then this is GMS, and which is cherty. So GMS is graphite mica cyst. And CS is calcareous cyst. No, CS is not calcareous cyst. Here it is calcilicate. A variation of dolomite, which is calcilicate. Okay. Then GO, which is again dolomite. Then there is dike. Then there is GBS. GBS is graphite biotite cyst. Then there is GMS again, graphite mica cyst. Hybrid is kind of hybrid rock unit, which they couldn't identify. That's why they kept hybrid. Then there is this mica cyst, micaceous cyst. And then there is micaceous dolomite also. And then again, QBS, which is quartz biotite cyst. Then there is quartzite. QZ is again quartzite only. And then there is a shear zone. The shear zone is pretty much important because this ore body has gone through a malanitic shear zone. And this terrain is completely a high grade metamorphic terrain. So wherever you are seeing this quartz biotite cyst or this GBS. So this is not graphite. This is GBS. Sorry, have I mentioned that GBS to be graphite biotite cyst?
Yes, sir.
So change it. This is not graphite. This is garnetiferous biotite cyst. It's a high grade metamorphic terrain, and this garnetiferous biotite cyst sometimes also carries sillimanite, which is an indication of high grade metamorphic terrain. And the rock and the ore is mainly hosted in graphite mica cyst, GMS. And some of the ore, which is dolomite, which is lead, is also hosted in dolomite and calcilicate. Okay.
Yes, sir.
So that's the pretty much knowledge about this area. Now the data belongs to a very important mine of lead zinc, which is one of the world's largest mine right now, and one of the second largest, which is Rampura. Okay. Now let's go back to the software. Screen is visible. Software Datamine Studio is visible.
Yes, sir.
Okay. Now let's go to a new project. How the project starts, you have to create a new project. Then this window pops out where you can select the project name. You can set the location of the project. Say I'm going to set the project in database, and then I'll go to my DM tutorials, then training folder. I'll create a project here. I'll keep the name of the project as training. Okay, training, then the folder location is selected. Now I'll go next. Now here this section shows whatever files are there in this folder. Right now there is only one Excel file and zip file which is getting added up. If you don't want to add the zip file, you can select that and remove it because that is not required here. Excel file you can add, or you can and if you have any other datamine files which you want to add, you can click and add files also. But right now we have this only one file. We can add this. Next, finish. When we added it, you will see in the project file control bar, in the training section, all files, you can see the training data in Excel format. Okay, so that is there also. Now we have to create a datamine file of these four files, assay, caller, survey, assay, litho. So what we'll do, we'll go to, there are multiple options. I'll show you the one option which is using the toolbar, which is there in the control bar. Within that control bar section of project files, there is a toolbar called import external data into project. So you can go there, click the import section, data import, and then there is, because right now the file is in Excel, not in CSV. So we have to import an Excel file. Sorry. Any problem?
No, sir, go ahead.
Okay. So now you have to go to, because it's an Excel file, so you have to click ODBC. Click ODBC, then go to tables and then click OK. Then it will show you a select data source where you can go to the machine data source tab, and then you can select Excel file. Then this window will come up where by default, because the project within that project file only the Excel file is there, so it is directly showing the Excel file, or otherwise the folder location is different. Then you can go browse through these areas in C drive or D drive, and then you can go to that particular location from where you want to add the file. Now you can go to training data, because here is the training data file where my assay caller litho survey is there. So I'll click this training data, then click OK. Now what is visible? All the table files are visible, all the sheets, assay caller litho survey. Sometimes it doesn't get visible. Then you have to check using this, clicking this table or the system file. That will show you. Now, when I'm clicking just the table file, it is just showing a file database link, not the actual file. So you have to click the system file to see the actual files. So when you click the system file, then you can see the assay caller litho survey files. Now you have to click only one at a time. So first you have to import caller. So you click caller, then click OK. Then these are the files: bhid, xcolor, ycolor, zcolor, and depth you want to import. Then okay. You can here put a name. You can remove the $sign. $sign generally locks the file. So you can remove the $sign and then import it. So the caller file is imported. Now there is a strange thing happened, which you can see. It has got into the caller file section, but it has not get into any, it has not created any another folder called caller. It has created just a table file because this is a caller is a table file. If I open it, you can see this is the table file. Now, if you open it, you can easily see that the bhid is not in color, is in plain color, but the XYZ are in blue color. Blue color means that it has identified, the software has identified them as a coordinates critical to the for importing. But it is also important for a bhid to get identified. Otherwise, it will not create a proper file. Now, what is the reason it has not created a it has not identified it as bhid? Can you guess? Can anyone guess?
Sir, it doesn't have any geology file. That's why.
No, it is a caller file, just a caller file. I'll go back to the Excel file again and open it and go to the caller. Now, can you tell me what is there any error you can see in the headers?
Because the format, like it should be bhid, but it's
BIHD is written instead of BHID.
Yes. Yeah, so that's why it has not identified as bhid and it has not taken the caller file. So if I edit it, say I change it to bhid and save it, and then I'll close it and go to the caller file again and right click re-import. Sometimes it happens that it refreshes, sometimes it doesn't. If it would have refreshed, then the caller file would have updated, but because it is showing an error, so what we have to do, we have to delete it. Error. I can, so for example, it has closed. Now I need to go to the same project, then I will not create a new project, or the project is also not getting reflected in the recent projects because it abruptly, before saving, it got abruptly closed. So you have to go to open project and you have to go to that source location, this PC, Windows C, database, DM tutorials, training. You will see the project file and you can open it. Shit. There. This is the loophole of using dash. This is getting recorded, na?
yes, sir.
I will not try it again because it's going to happen. So I'll create a new project. Next. Training 2. Same location I'll select.
Way of learning. Yes.
Okay, so I'll quickly do the same process. Caller, ODBC, tables, okay. Machine data source, Excel file, training data. And then I'll select caller, okay. So caller is here. Now if I see, correct ho gaya? It has shown as in green now.
Okay.
So for
Yes.
that reason, you can see another folder get created, which is called caller. So that means your caller file is correct now. And if you open the table file, you can see the green color shows the original fields of which Datamine has easily able to understand and read. And it is a reference file, which is important for the software to run any command. And similarly goes for the blue ones also. Now here in the table file, there is some other points to remember. If you see in the BHID, in the bracket, it is written A12. Can you tell, anyone tell what does it means, A12?
That
Look,
means,
I'm going, yeah, tell me.
yes. Sir, it means it should be in alphanumeric, and it will take only the letter between 12 letters.
Yeah, so it not should be. Actually, what it is saying that this particular column is alphanumeric, you are right, which is that's why A, and the maximum words that it is carrying is 12. Okay, because you have imported it, so we have not defined what should be the maximum number of characters. It has automatically identified that the maximum number of characters that it is having is 12. So that's why A12. Now, for example, when you imported this, and this is one column which is going to be consistent in all the other files, because BHID is going to be there in all the files. Now, by mistake, if it happens that in some other column, some other file in BHID column, there is more than 812 characters, then it's not going to import properly because it has freezed it as 812. So it is going to import, but when you will do the desurvey or the validation, reload validation for combining the whole, it will not take, because the alpha number characters, the maximum allowed characters is different for different columns. So these are also some of the uh, methods to check for the errors, because it has to be consistent. BHID is never going to be different in different columns, in different files. So these things helps us to correct the file also, to understand the errors and to correct the file also. Now here in X color, Y color, Z color, if you see, there is written N. N means numeric, which means the numbers are, the column should be or is currently in numeric format.
Yes, sir.
Okay. Now
And
this window which I opened, this is called table editor window, where I was double clicking and checking. So this table editor window also carries, you can create a new table editor. You can open a file like this here also. You can edit something here and can save this table editor. You can search for different areas. You can add columns and rows in this table editor as well. Just like Excel, you can do it here also. But it is generally advised that if you are linking something with Excel file, do the correction in Excel, because as you have seen the BHID, I could have corrected it here also. I could have gone in this table, and here by clicking in the BHID, I could have edited the BHID here also, but I didn't do it because the original Excel file would not have changed. So I corrected the original Excel file and then used it again. But if you want, you can make the corrections here in the table editor also. Yeah, anyone, someone is having some question. Yeah.
sir, one more question is, why it identifies as the green color and blue color, difference between them, as it is identified, these are my files and it will take my identity, like these are the porthole ID and these are my color. So why it is kept like green and blue? What is the difference?
Green and blue, if you see here also, just by seeing these four tables, it is highlighting the green field, which is having a alpha character category field. Okay.
Okay.
And the blue ones are the numeric fields, which are having the coordinates. So that's the basic difference between. So green ones are the important category fields which are required to define a file,
Okay.
and the blue ones are also important defining a file, but it is actually the coordinate locations of the file. So it is showing the locations. So the X, Z, Y, these coordinates, these things, or if there is any numeric sample field which is required, so that will get populated as important field. But all the category fields that are required and important, that gets populated with green color. Because the file is getting defined by the green ones. And the property of those green ones are mentioned in the blue ones.
Okay, okay.
Understood?
Yes, sir.
And this goes for any any file. So the any file which is getting defined, that will be by green color, green columns, and the definition of those green columns are there in the blue columns.
Okay.
Okay,
Yes,
fine.
sir.
So color is done. Now I'll import another file, which is again machine data source, Excel file, training data, survey. Now there are two dip. Now the reason of having two dip is because, as I mentioned earlier, it is in local coordinates. So what happened? The original dip was in dip 1, and then they converted with subtracting or adding with the rotation angle to get the local dip. Sorry, not the dip, local, local bearing, not the dip, local bearing. So they mentioned it wrong. So so basically the bearing is getting changed here, but we will use the first 4 columns, not the dip one. So we will use PHID, add bearing and dip. Date is not required. It is mentioned for there is some reason only, but we will not use it. We'll use only the basic fields, PHID, add bearing and dip. Open, remove the $sign. Okay. Now you can see the survey file is correct. That's why a folder named downhole survey is created automatically, and the file is is created in this file, and it's all are green. So these are all are important category fields that are required. That's why it is in green, which defines this file. So all these green files are required to define the define this particular file. Now the survey is done. Then we'll import. Okay. Now I have shown you how to import it through Excel file, but you can import these files using CSV as well. So the remaining 2 files, I'll use the CSV format to import. Okay, so that you can understand both the process. So I'm not going to import it as Excel. I'll go back to my folder again and this training data. And I'll convert the SA file and litho file into CSV so that I can show you how to import from CSV. So file, save as CSV. This is my assay data. I'll name it as assay. Same location, save, okay. And also the same thing for litho. I'll save it as file, save as CSV, litho, save, and I'll close it. I'll not save it. Don't save. Okay. Now you can see 2 files created, assay and litho, in CSV format. Okay. So I'll show you how to import in CSV. Now the same location data import. Instead of ODBC, now you have to select, because it is CSV text file. So you have to select text. Then again, go to tables, because it is a table file. Then OK. Then go to the particular location. Go to essay. Now in text format, you will see this is how it is coming. It is coming. Okay. So because it is a text file and you can see they are separated by comma. So you have to select delimited and then click next. And in delimiters, you can select comma, then it gets separated for each of the columns. If it is using something else, any file, say tab, then you have to use tab. If it is differentiated by space, then you have to use space. But here this is by comma because it's a CSV file, comma separated file. So that's why we are using comma. But in some cases, like for example, if you are getting some geophysical data points or geochemical data points which you want to incorporate, those text files generally may have space in between or may have tab in between. Then in that case, you have to use tab and space and see if it is creating columns or not, separate columns for each or not. Then next, now you can see here also, this is BHID. If you click this, this is coming as from, and the attributes are mentioned here. So for BHID, it is an alpha attribute. And for from, it is a numeric attribute. Now, if you go to the sample file, it is again a numeric attribute, which is lead for lead. Now, if there is any absent value, how you want to treat that absent value as? There is no absent value in this case, but if some case there is any absent value, you have to click the special value and you want to treat absent value as dash, not as 0 or any other number, because you want to treat the absent area as absent, not as any number. Because if you consider an absent area as number, the estimation will give you a different result. And if you consider the absent area as absent, the estimation is going to give you a different result. Why so? Can anyone explain or can anyone answer? So the reason is, for just imagine there is a file, there is a column file, which is having some numbers. Okay. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now tell me, if I average 1 to 10, what is the average value?
Like it will be 5.
Let's do this in Excel. Say I have some numbers 1, 2, 3, up to 10. Okay. So the average will be what?
5.5.
5, 5.5. Okay. Now, if instead of say 5, I use 0, average is 5, right? And instead of this, if I use absent, average is 5.5. So that is the impact that will have to any estimation. So if you use, say there is a blank area and you don't know what is there in that blank area currently, because that has not been estimated or that has not been analyzed. If you use 0, then you are presuming that this area is having no value or 0 value. That's the way you are estimating, and that's why your average will become, or composite average will become different. And if you say that I don't know what is there, so I don't want to use that particular area in my estimates, and I want to treat that as absent, then your average value will be different. So that is the impact that you are going to create on identifying an absent value within a sample file as absent or as 0 for your estimation purposes. Clear?
Yes, sir.
So from now on, anyway, anytime when you are seeing a sample file and you are seeing some 0 values, or you have to check that is these 0 values are actually 0 or absent values. Because sometimes what happens, some people when give you data sets, they generally tends to use the absent areas as keep as 0. But if it would have been actually a 0 value from analysis, it cannot be 0 in that case. It would have been something like this, right? So that needs to be clear, that if it is actually analyzed or it's just plain as kept as 0. Sometimes it happens that the logging geologist can say that no, this is actually 0. That's why we have not analyzed. And if they're confident and the geological log is also saying that, yeah, this area is barren and this should be treated as 0, then you can use 0 also. and can estimate the area as zero value. Okay, so I'll just use as absent for that for now, and for zinc value also as absent for the areas where there is no values. Finish. Now, when you are using text, it comes as essay underscore text. You can keep it like that only, or you can remove the text and say it as essay. Now, if you see, the essay is completed. Yeah, but there is no. My voice is not audible.
Sir?
My voice is not audible. Hello.
Sir, your voice is not audible.
Not audible. So how much you have listened? Up to which? Am I audible now?
True, sir.
Hello. Hello, am I audible?
Yes, sir, you are.
Shiny, am I audible?
Sir, you are saying something, but we cannot listen. We can't hear you.
So what did you listen? क्या समझ में आया अभी तक? और क्या नहीं आया? कौन सा सेक्शन आया नहीं आया?
कुछ भी नहीं आ रहा है आवाज.
अभी मुझे बताओ किसको किसको सुनाई दे रहा है क्लियरली और किसको किसको नहीं आया?
सर ऑडिबल है आप इधर लखनऊ.
लखनऊ में समझ में आया क्लियरली?
Yes,
मैंने जो
sir.
बोला.
Yes,
Audible
sir.
है.
और
Yes, sir.
भुवनेश्वर में समझ में नहीं आया?
Yes.
Maybe we don't have a proper network.
अच्छा, tell me, Shiny, can you hear Akash and Ali clearly?
Everyone is talking, but we can't hear his voice.
Hello.
Yes, sir.
Yes, sir.
Shipali, can you hear? Hello.
Sir, they
I
are
think
having
उनको
some
सुनाई नहीं दे
network issues. Yes, sir.
Sir, your voice is not
Sir.
audible.
Can anyone call them and say that you all are listening?
Yes, sir, I
Can
will
you
inform
listen?
them. Yes, sir.
Yeah. We can wait if they want to reconnect. Vijay, is it audible to you? Okay, Vijay is saying you're audible here. Praveen, is it audible to you there?
Yes, for me it is audible.
Okay. And is the recording going on?
Yes, sir.
Double time. पता नहीं.
5 minutes break, guys. तुम एक बार sort out कर लो. ठीक है।
Video is not coming here.
हेलो विशाख सर, आवाज आ रहा है हमारा?
हाँ हाँ
हेलो आकाश भैया, कुछ बोल रहे हैं आप?
आवाज आ रही
हाँ।
है श्रीपाली, ऑडिबल हो?
मैम कुछ बोल रही, कुछ आवाज ही नहीं आ रहा है।
लोग ऑडिबल हो इधर।
हेलो हेलो
Hello, yes, Shripali.
yeah, now you are audible clearly. Thank you so much.
Okay, thank you very much.
हेलो मेरे पराठा खाएंगे? पराठा खाएंगे?
पराठा नहीं चाहिए, क्लियर ऑडियो।
अरे ज्यादा दे गया, 4 पराठा दे गया। स्विगी से मंगाए थे। ठीक है।
Thanks. ठीक है मैम, सुनाई दे रहा है।
अभी ऑडिबल है?
यस सर।
प्रियंका?
Yes sir, yes sir, it's clear now.
Okay. So tell me कहाँ तक समझ में आया? From where you want me to repeat?
So only up
Shiny?
to that
essay. That essay
Only up
file,
to-
you have converted that into CSV now? From that.
Yeah. Okay. So I'm converting the essay file again. I hope the screen is visible.
Yeah.
So I'll go to the text file because it is a CSV file. So you have to go to the text file, and then go to tables, import, select the CSV file essay. Now, if you see here, it is delimited is selected because it is a comma separated file. So you have to select delimited and then comma. Then we will see it gets separated into different columns, which is as required. In some cases, it may happen that some point files may have space or tab. Some different types of text files may have space and tab. Then you have to select space or tab to separate those columns. For right now, it is because it is a CSV, it is a comma separated file. So I'm using comma. So it's getting separated in different columns. The next, now if I click in BHID section, which is highlighted in black, it is saying that it is an alpha file. So that is fine. This is an alpha file. Then if you click in from, it is showing this is as numeric file. Now there is an option which is for special values like absent data. So for example, in this geochemical data, which is lead value, if there is some absent values, how you want to treat those absent values? Do you want to treat those absent values as absent, which the symbol is this generic dash, or you want to use it as 0 that you can mention here. So I'll be using as blank because, as I mentioned earlier, showing this example of Excel file, say there is numbers from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the average becomes 5.5. But if I replace 5 with 0, the average is 5. And if I replace the 0 value as absent, the average is 5.5. 5.555556. So that is the difference that you are creating while selecting an absent area as 0 or as absent or as some other value. So that's why it is very much critical to understand, to see where the absent values are. Is it really falling in 0 areas, or is it falling in the ore body zones, or in the areas where there should be some value, but that has not been analyzed. So that needs to be critically checked, and then only you should assign absent or 0 in those areas.
Okay, sir.
Now coming, so that's all in this area, and then I'll click finish. And in terms of underscore text, I'll remove the text file. You can keep it like that way only, but just for sync, I'm keeping it as if as naming as the essay file as essay. You can also see one more thing is the location of the file. Here you can see the location of the file is going to the same folder where the project is. If you want, you can change it, but generally when you have to desurvey a file, all the related files should be in the same project, in the same location where the project is. Then click OK. Now you can see there is no separate folder which is created for essay. It has gone into the table file. The essay file has gone into the table folder, but there is no other folder which is created for essay like caller and download survey. So there may be some error. That's why it has not created. Otherwise, it would have created a separate folder. So let's go back into that essay folder and click it and see what is there. Now BHID is okay. It is showing as green. Now if you see to length is showing it's perfect, but the from is not getting highlighted. Can you tell me the reason? Can anyone tell me the reason?
Sir, it is in small letter.
Brown is not in caps.
Yeah. So I can go to the table editor and select the from, and I can change it here also using caps and apply. Then it will get corrected and it has been shown as green as critical field. You can do it here also, or you can go to the Excel file, the CSV file. Open it and change it, correct it with caps. Save it. Go back to the software. Close the table file. Don't save it because I want to keep it as it is, as small. Yeah. So you can correct it here. You can either re-import it, or I mean, you can directly re-import because it is not highlighting. So you have to re-import again from tables, essay. Sorry. Now, if you see, the essay file is created in the essay folder, and which is right, which is correct. So ideally, you correct the Excel linking the linked file and import it again so that all your files are correct. Now I'll import the last file, which is the geology or the lithology. Same process. Okay. Now the lithology is coming also under essay folder. That means that is correct. All fields are correct and the codes are taken. So my drill hole, for creating a drill hole file, the basic files are ready. Now the next process for creating a whole file is you can go to this batch command or the command prompt area and can click and can write HOLES and 3D, holes 3D, and enter. So this is one way of creating a dsurvey file. The other one is you can go to the menu bar also, because the menu bar has changed a lot. So I'm also not that comfortable, but I'll try to check from where we can go. Can anyone help me? Should have been here only in the data section or in sample analysis. Yeah. So if you go to menu bar, data, external, and then there is a name called dsurvey drill holes. So you can click dsurvey drill holes. No, it is importing. Not this one. This is not that.
Sir, in sample analysis, I think under whole wizard.
In sample analysis, under
Whole wizard. No.
where is this? Yeah,
No,
this
no,
one. No, I don't think. No, it's not this. Lot has changed in RM. So
Sir, I
and
think
there
it
is
is
a
in home. If you go to home, data, where is that import option?
No, import option is in data.
Data, na? So click on data, sir.
data.
Import to project.
Yeah,
It is only
import to project is there. So import to project is this only, this section, what we have done. So that is
Right.
this only, the data import.
Mhm.
DH logger, drill dsurvey drill holes, DH drill holes, dsurvey should be somewhere on here only. Yeah, dsurvey drill holes. In data, after point string wireframe, dsurvey. No, this is also no. This is also importing. ठीक है, मुझे भी नहीं मिला. will find it, or if anyone finds it, can share to everybody. Now go to batch command and you can click holes 3D. So this is the window that comes out. Now here, if you see, there are some areas which is in color yellow and some are in white. The yellow fields are compulsory fields. So that means if you fill those yellow areas, it will create a whole file. So if you see in survey, this is not highlighted as yellow. That means if you put a caller file and any sample file and give output to that name, it will create a whole file. But the whole file will be vertical because there is no survey file. So it will consider the whole drill hole as vertical and will plot it as vertical holes. So if I go to caller, I selected, let's not select survey and see what happens. And then I'll go to sample one, which is now for each of the command in batch command, we will see whenever you click the section, there is a help at the bottom, which says what it does or what it requires. So you can go through those sections also to understand what sort of file is required in these areas. Now in sample one, it is requiring a file which is having borrow ID from and to and all the values. So which means either SA file or a lithology file. So I'll go and select I select SA file and click OK. Then my sample 2, I can select lithology file, which is not compulsory, but I'm selecting. I have not selected the survey file. OK. And I'm giving an output name, say HOLES holes, and a summary file name, say SMRY, to get a summary file, and array file name as ERRORS as array file. Then fields, already I have selected caller, so xcaller is my xcaller, so this is I have to keep it as default. If my xcaller is changing in some cases, in some cases where you want to change the coordinates, then it's required. Otherwise, it's going to be default always. Then the parameters, you can see the survey method. Survey method is what? Is equal to 1 to add samples where there are more than one survey record per sample. So if there is a survey file and there are more than one record, say at 0 there is a survey value, then that at the bottom 30 meter, 40 meter, 60 meter, at every 30 meters or 100 meters, there are additional survey values, then you have to keep it as 0. Keep it as 1, so that it can accommodate different survey values. If you keep it as 0, then it will consider. So that's by default, it is 0, it is at 1, and let us keep that way. Now endpoint is when it is 0, then it will generate only for particular whole file. For each of the break in the drill hole file, it will only generate XYZ of that center point, midpoint of that from 2. So for example, there is from and to. So you say there is from 0 to 2 meters, there is one code, and from 2 to 5 meters, there is another code. So the position of that 0 to 2, it will give XYZ of the center position of 0 to 2 when the endpoint is kept as 0. Now, if you change the endpoint to 1, what it will do, it will give you the starting coordinate of 0 to 2, as well as the center coordinate of 0 to 2 and the end coordinate of 0 to 2. Sometimes it is required when you have to provide the starting depth somewhere, in some cases when you have to provide the starting depth of the sample location, then these files are required. So in general case, I generally keep it as 1 so that I could get all the information. But to make the file little bit less heavier, you can also use 0 to just get the center coordinate of x of each of the intervals. Now, dip method. Dip method is actually 1 is kept for if the downhole survey data is saying the dip amount is in positive for downhole data, which is going downhole, then the dip method is 1. If you consider the downhole as minus dip values, then you have to change it to -1. So it happens somewhere in some cases. For example, uh, here also there are some underground holes, but in ideal cases, what happens, in underground, the plus holes are considered to be holes above the surface towards the sky, uh, and the down holes are considered down to the towards the ground. So that's why the negative holes are kept as down the hole, are kept as minus holes, and plus holes are called as the holes which are drilled upwards. That is done generally in underground areas, but here for convention we have also changed in this particular file which we have shared. So here the down hole is plus and the up hole are kept as minus. So we will keep one plus one only, not the minus one. Now if you have sometimes used the SURPEC file, the SURPEC file also has a similar issue. SURPEC file generally considers the down hole as negative and plus so up hole as positive. So when you are bringing a SURPEC hole file to the Datamine file, then you have to be aware of the survey dip direction. Is it in plus or is it in minus to actually properly convert it into a proper downhole survey. Otherwise, you can mess up with the drill hole data. Now, another key thing, what do you mean by dip of the drill hole? When we are saying dip amount, you should understand what is that dip amount and what is that angle is. So for example, if I'll go back to the paint and new. Now, for example, there is this surface. Okay, so let's say this is a topography and you are in a cross section and you are planning a hole. Say this is the drill hole. And say this is your west and this is your east. Okay. Now this is the hole. Now for what is the dip angle here in this case? Is it the angle which it is making between this and the vertical imaginary vertical line, or it is the angle which it is making with the downhole and the horizontal line? What is the dip? Anyone?
Horizontal
Louder.
line.
Horizontal line. So the dip is actually nothing but it's this. Okay, not this one. So when we are talking about dip, so this is the angle which it is creating. Why? Because dip direction or the bearing is this is the direction which is giving you the azimuth. Okay, which is right now west, but if it angle changes, then it will be something different. So this is the dip amount and this is the bearing. This direction is the bearing. And this is the particular drill hole. Understood?
Yes, sir.
And this is called downhole and uphole is this one. If your drilling is like this, that is uphole. So it can't happen in surface, but if you have a underground drive, say this vertical line is a shaft and there is a drive and you are drilling from the drive to intersect a O body. So this drill hole is downhole, and if you drill another hole like this is your uphole. And in our case right now, the downhole is positive, uphole is negative. But in many cases, the uphole is kept as positive and the downhole is kept as dip is kept as negative. And if there is any horizontal hole, that is just a horizontal hole with a zero dip. This is a fan-shaped drilling which happens from drives, underground drives. Understood?
Yes, sir.
Okay. So this is dip method. Then there is prompt. It is default for a prompt of a pause or execution. And print, you don't require a print file of this, so it's fine. You can keep it as 0. Now I'll click OK. Now the command prompt will come into action and it will show the process. And if you see in the status bar also, it shows the status of the run, what it was running. And if I take the cursor here, observe here in this area at the bottom cursor point location, see, whenever you are in window, it will show you X, Y, and Z. And if you double click this is the mouse position. And you can lock the Z, X, and Y also to change. Now my drill hole process is complete, but there are some errors which it is highlighting. Like for example, it is saying that the survey is complete. The survey file is in holds. The file contains 5,511 samples. However, data validation warnings have been issued. This may affect the integrity of the survey data, and so the input data files should be checked thoroughly. The data problems are summarized in the file errors. So we will go again to the project control bar, and we'll see in the SA folder section, there is another file which is created, which is called errors. And there's another folder which has created, which is having the drill hole file. But currently this drill hole file has some errors, which we can see from the command prompt. So let's check that error file and we'll try to rectify those errors. Now, what does the error file showing? It is showing a different type of errors. Okay. So basically in Datamine, there are broadly 3 type of errors, which is shown here. So one is having some absent, then there is duplicate error. There can be duplicate errors, or there can be, so the 3 type of error is duplicate errors, and then there can be from to error, or there can be no file or no survey error, or sample overlap error can be there. So what it is showing in caller section, so in file caller, the problem is there is absent caller, where in borrow ID there is some absent callers. Okay, the caller is absent. Similarly, there are 4 files which is showing absent callers in these 4 files. So we have to check these 4 files. Then also in the caller file is another error which is saying that there is duplicate caller. So this borrowed ID is getting duplicated. So we will address one by one each of the file. So let's start with the callers part. So AHD and 2254. So let's go to the caller in the project window. Let's open the caller file and let's make it a smaller so that I can simultaneously check the error folder as well. Okay. So now if you see in my error file, what it is saying, ADH and 2054 is absent. So it is not here. So how we can check it? Because it is not here, so we can't check it here in this caller. Is this file is having any error, or is there any duplicacy? So for that, we have to also again open another file which we have created, which is called summary. Okay. Now in summary, if you see, there are some areas where caller is absent, but it is having the other 2 sample files, as well as there is no survey file also for that particular file. Okay, so that means, for example, this file is not having any caller file, but having SA and sample file. Now, if I go down, there are some areas where there is no sample file, but caller file is there. Right?
Yes, sir.
So it may happen that there is some mistake in the naming of the BHID. Why? That's why there is a caller file, but no SA and survey file. But there are some areas where there is no caller file, but SA and sample file is there. So that needs to be checked properly. Is there any duplicacy in typing, or is there any space left behind in BHID? That's why this is happening. So that also needs to be cross-checked properly. See, there is another file which is saying there is a caller file, but no as a litho file. Got my point? So these are basic errors. I will ask you to also to go through it and check it when you will be doing it. Right now I'll just correct those files, but you have to cross check and correct those. So let me
Yes.
see if I can do it here only or not. So say AHDU is 4074. Let's take this in Excel. Let's check what are the absent values in column. Okay, these are the absent values in column. I'll color them. Now, for this, if you see, this is having no color, no sample file. Only one sample file, which is lithology. So maybe it may happen. No, sorry, it is having only sample 1 or sample 2. Yeah, only having lithology. So it may be that it may happen that this is having only this file and rest of the information is not available for. So for current process, you may have to ignore that or delete that from the original files to carry it forward. But for the remaining, we have to check because there is caller file but no sample file, and there is other areas also where there is no caller file but sample file. So we have to cross check. Like for example, let's check AHTN 8711. So let us sort it. Data sort. Now see, here ASDN minus 8711, and then there is yeah, let's do it for this first. I'll come back to here. So here it is written AHDN 111. So 100 means it's basically a 100 MRL whole file with number 11. So 100 MRL 11 whole number 11, and this is 100 MRL whole number 2. Now let's see if there is anything at 100 MRL. Because I know about this area, that's why I can say it. So you have to first know about have to have a complete idea of the area, then only you can work on it. One sec. I think I have to delete this. So let's filter 100. I'll show you only one because it's going to take a lot of time. You can test it after the session to correct try to correct all the files. Now, if you see, these are the 100 MRL holes where there is this 53, 56, then it is 58. So 58 is the last, I think it's one of the holes in 100 MRL. Now let us check if there is any hole which is showing -100, or is there any text error? Okay, I can't also see right now. Let's check for the some others 0040. So this is having now only one sample file. Okay, I couldn't make out any physical error by visually seeing it. So maybe I have to dig deep, or you have to get back to the person who has given you the data and to cross check it. So let's not get into that detail. Now let's go to the other error file and see what is there. So after caller, you can see there is there are some callers which are showing duplicate callers. Now let's address those duplicate callers first. So ADH 1009. So let's go back to the Excel file in caller. And here, let's search for which file? ADH 29. Okay. Sorry, ASD. कोई बोल नहीं रहे हो?
Yes, sir.
Yes sir, थोड़ी बोलना है. ADH कर रहा हूँ, ASD बोलना है ना? So okay, ASD 29. ASD 29. What they are saying, there is a duplicate caller. But if I see here, I'm not seeing any duplicate callers. Can anyone see it? Because Excel file is all with you also. You can check also if there is any error. What is the error it is actually talking about? I can't see any duplicate callers. Okay, yeah, here it is. See, there is again ASD 29, and here there is again ASD 29. Now the coordinates are almost, I think the coordinates are same. Yeah, the coordinates are same. So you maybe by mistake these has been repeated. So you can remove one caller file and keep one. So similarly, let's go again. Check for AHD35. That is also duplicate. So let's check for AHD35. So this is also showing two duplicate files. So let us remove one. Then AHD 36, 37, 39, and 40. So these are also repeating. So let us remove them. Fine. The one error is removed. The duplicate error is removed. Now let us check the SA file. SA file is saying that there is duplicate from tool in AHDE0503. Let's copy it. And let us go to the SA file. I'll close it, close the caller file, save it. SA file is in CSV, so we'll go to in CSV SA file and we'll open it. Okay. Now what it is saying, Control F, this file. So let us check this whole file. So this is the first file only. So in here, it is saying there is a duplicate error file at 63.5 to 64.5. So see, there is two files of 63.5 to 64.5. Sorry. Yeah, and but there is a difference in the length because there is added in the length also. So this file is but you can see that sample file is also having different grade values as well. Right?
Yes, sir.
So now there can be one error, one thing which is typical typing error. It may happen because if you see the continuous sample at before and after the area, so it is showing 62.5 to 63.5, 63.5 to 64.5, and then again 63.5 to 64.5, but then after that 66 to 67.5, which is 1.5, then 67.5 to 69, which is again 1.5. Okay. So there is a gap of 64.5 to 66, which is 1.5. So it may happen. The one way is we can delete it because it is repeating, but then what to do with the values? Because one is showing a different grade value and one is showing different grade value. So we have to be a little bit open with what is happening with the additional samples. But then again, whatever you do, you have to cross check with the original data files. But because I don't have the data files right now, and what I could understand from here is if we consider the length value as correct. So if I change this 60 to 64.5 to this as 66, which is coming as in the next sample. So this length becomes 1.5 and the sampling also becomes continuous. So this may be the ideal correction for this particular error. But then you have to verify it from the original data sheets again. But let us consider right now this to be the correct, most suitable correction, and we'll go ahead with this. So in that case, the duplicacy is removed. Now let's go to the next error, which is again in the SA file, which is saying sample overlap in Borel AHDN-871, which is 56.5 to 53.5. This is quite clear because the from 2 is got reversed. So we'll go directly to that whole file. And we'll go to that particular depth, which is this. You see here, this has become 56.5. So it should be 53.5 to 56.5. Now then, if I change it to 53 to 56.5, what is happening in the next sample? If you check the next sample is of 1 meter, which is 53.5 to 54.5. So every sample is at 1 meter length currently. So it may happen that after 52.5, there should have been sample called 52.5 to 53.5, and then 53.5 to 54.5. So what may have happened that this particular cell has been changed, not the complete reverse cell. So if I change it to 52.5, so it becomes 1 meter. So 52 earlier sample is 52.5, so it's fine. After that, it is starting again from 52.5 to 53.5, then 53.5 to 54.5, which is again one sample, then 54.5 to 56.5 being the 2 meter sample, which is having low grade value, very low grade, or maybe in the waste. So that's looks justifiable explanation. So we will make this correction in this file, and we'll consider this to take it ahead. Now let's go back to the other error, which is the other error. Now, if you see, the next error is 3755. 24.5 to 28.5, which is again showing a duplicacy of from 2. So let's go there and check. So what is the error? Error is it in 24.5 to 28.5. So let's go to that. Sorry for this sound. ये lift का काम चल रहा है यहाँ पे. So, okay. So if you see here 24.5 to 26.5, and then again 24.5 to 28.5. So the error, it is quite visible what the error is here in this case. It should be 24.5. Sorry. Yeah, it should be 24. No. 21.5 to 24.5, then 24.5. So maybe this is okay, and then 24.5 to 26 is okay. Then this should become 26.5, and which will be a 2 meter zone, right? Fine. So this is the error which we have resolved. And then again, we'll go to the next error, which is 29.03. To 30.4. Okay. Yeah. So what is happening here? What is the type of error? Again, duplicate from 2, go to 39, 29.0 to 30.4. So there is some repetition. So where is the repetition? You have to check. See, it is again repeating here. So you can clearly remove it because the samples are same. So this is the way you have to correct all the files. There is some errors in the litho also, which also needs to be corrected. So I'm not going to show all the errors. I've just showed you some of the errors. I'll just save it, close it. And what I'm going to use, I have a corrected whole file, which I'm going to use for further process. And this is going to be an exercise for all of you to check for all the errors and correct it. So let me check where is my file. Okay, I couldn't find it right now, so I'll use another file for the remaining process. Okay, I'll continue with this file and later I'll replace it. So I've replaced this whole file with another whole file, which is this. Okay, and this is having all the corrected whole files. Now I'll load it. How to load it, the whole file? You can load it by dragging and dropping it. So you can see the whole file displaying here. Is it visible? The screen is visible, right?
Yes, sir.
Okay. Now there are two methods to actually get the whole in the 3D window. One is you can directly drag and drop it. There's another command, shortcut command, which is called GD, which is for get results. If you click on the window and type GD in the keyboard, on the keyboard, so you will get this browser window and you can select the whole file. That also you will load the whole file. If you see, there are two whole files loaded now. Okay, so that's the whole file. Now, for example, the another important file which is required to create a to start a model is topography. Now, I don't have any topographic file for this particularly right now. So what we can do, we can create a topographic file using the caller file also. So I'll remove the whole file right now. So here you can see when you have loaded it into this 3D window, it gets also reflected in the loaded control bar, where it is showing the loaded file is whole Trilol file, as well as in the sheet file also. You can see in the Trilol folder, you can check this Trilol file. Now, if you want to edit this Trilol file, one way is you can double click on this sheet in this whole file in the sheet control bar, and this window will pop out. Or otherwise, you can also click on particular hole, double click on that particular hole, and then also the editable tool pops out and you can edit the file. Now what you can do is here you can edit the general like for example, the name of the whole file is there and the source is mentioned. Now you can go to lines and symbols. If you want a legend, say for example, how you want to display it. You want to display it in, currently it is displayed as pixel line, or you want to display it as default cylinder, then it will become displayed as default cylinder like this. Or you want a guideline, then you can also have a guideline which will be at the center, going through the center of that cylinder. And then you can increase the scale size by, may say you increase it by 8. So that has increased. Now, for example, you want to have a size, and for size, if you have a different legend for to show it in a for different O grade, or for different lithology, you want to have a different size, that can be done through this legend and column using this, or you can keep it a constant scale. Now for coloring, you can color the downhole using this tool. So say you want to color it using the lithological information. So right now I don't have any lithological color for lithological information. If I go to rock code, which is litho code, which is here, there's no currently default, all our default lithos and information is there. There is no legend prepared. So you can create a legend by clicking here, edit legend, and then going to new legend, use object field, holds file, and you want to create a legend for lithology. Go to lithology. Next, it is currently getting saved in current project file. If you want to save it in legend storage, you can click the user legend storage also, and it will get saved in the user legend storage. Now let us save it in current project file right now. Next, you can change the name of the legend if you want to, or you can keep it as default. Let us change it as just as litho, or say edited litho. Now you can keep a range or a unique value. Because you are doing it for lithology, it will be a unique value. If you have done it for, if you're creating a legend for any numeric value, then it would have been it would have been in ranges. But because it is a legend correct category field, so we will be using unique values. Then next, so there are 45 items in lithology. So there are a lot of lithological codes which needs to be corrected and combined. So that is other part of the story. So these are the edited lithology colors. Now you can change the colors by clicking in each of the lithology. You can change the colors here, selecting any color. Now you don't want a solid color, you want some other texture, then you can select a texture also and change the texture from here, going here. If you want the color textures, then you can go to color texture, then you can select color texture from here also. Okay, so there are different methods of selecting textures. So this is for fill style. The line style can also be changed. So if you want a solid or a dash line style, so those can be done. And accordingly, the legend color will get him. So I'm keeping it default right now, only for, but for the GMS value, I'll change it because that is my host package. So I'll change the GMS color. Let's change it to gray, and I'll change the dolomite. If it is visible, where is dolomite? Calcilicate. I'll change it to say magenta, and if there is dolomite. Can anyone see DO? No. No, there is no dolomite. Okay. Apply. Okay. So that way the colors will change. Now it has not applied here yet because you have just changed the lithology. You have not selected it. So you have to go and select the column litho in the drill file where you want to use a legend, and the legend is litho, edited lithology, and then apply. It will change accordingly. Okay, all the gray zones are showing the GMS area, which is the basically the host package. Now, say you want to label the drill file, so you can click on display level and you can add the BHID level, select the BHID level here, and with whatever color you want to apply, then you apply it, then you can see the text. Now you are seeing at the text at the collar. Now if you want to change it to end of fold, you can do it here by clicking and applying end of fold, or in segments, so you can do that as well. Let's keep it at end of fold. You can offset the text as well, depending on how you want to see it. So there are multiple options which I suggest you go through and check. Then there is columns. Now you have colored the lithology on the drill file. Now you want also to display the grade. So you can't display both the items together in one column, in one cylindrical area. So let us, for example, you have populated the geology in the cylinder along the downhole. Now you want to see see the grade, and we can populate it as graph as an additional column. So for that, you have to click in the columns and go to display downhole column, click it, and then insert. Let us insert zinc. Okay. So now if you see, zinc is going to be displayed in the right hand side. on the right hand side of the downhole as zinc. Now you can select how you want to present it, as a graph or as just as a border. So if you want to apply as graph, so you can go to the graph and you can select what type of graph, field histogram or just histogram or line graph or bar with annotation. Let us keep it as field histogram. And we are populating zinc. So column will be zinc and there will be legend. Currently, this is the legend, but you can change the legend again by going through the same process of editing legend, creating a new legend for the whole 3D, going to the zinc column. Now, because it is a numeric now this time, you're creating ranges. Ranges. Next, let's keep it to 5 only. Next, equal with equal population is statistically, if you want to display it as whatever samples are there, you want to distribute it equal with, or whatever sample distribution is there, you want to distribute it with equal population. So population will reflect more the grade variation that is there in the deposit, and equal width will just display as the numbers of intensity of the samples which are there. So generally, what I do, if I want to check the grade variation, how the deposit is having what can be the geological cutoff and all, I generally use equal population, because that will give you a better idea of the variation of the cutoff, the geological natural cutoff which is there in that particular geology. So equal population, if I select next, finish. So if you see here, now it has been populated. So you can clearly see the grade ranges that up to 0.0378, there is a range, there is some good number of samples. Then there is a natural cutoff at 0.378 to 0.487. Then there is a natural cutoff at 0.487 to 12, then 12 to 20, 20. So this is giving you a broad idea of how the geologically it is distributed. Now you also know for zinc, the natural cutoff for any economic cutoff, generally what is capped is 2%. At greater than 2%, you can consider that to be economic. So what we will do, we will edit this area. So we want an area of, say, for in the ranges below cutoff, let us make it at 2, so that below 0 to 2, everything will treat as waste, and then 2%, greater than 2%. So we can keep it at 4 and 5, because that is a middle level grade. So 4.87, I can make it to 5. So 2 to 5, it will give you a grade. And then from 5 to 12, it will give another range of grades, which is right now the same color is shown as green. So let us change the color. Let us change it to maybe, let us make it yellow, pale yellow. Then the orange color from 12 to 20, and then greater than 20. And this 44.92931 is the highest number of samples, so that's fine. So we can make it round figure at 45. So 20 to 45 is red. Okay, so that's done. Now in the legend section, there are 3 areas in the legend. So if you see here, there is a system legend, user legend, and project legend. Right now we are creating it in project legend, which will remain with the current project. Now, if you want to copy it down to the user legend so that you can use it in different projects, that also you can do. You can just copy it here, copy to user legend. So it will get copied at the user legend section. Then you can use it in later in other project files also, because it is getting saved in your user legend. Similarly, you can save it in system legend as well, but the systems are better not to disturb, because these are some important legend colors which is kept for, like for red is kept as this code. So these are some system files, standard color distribution is there. So let us not disturb that and keep as it is. And it's better if you want to keep some legends, you keep it in user legend. And if you are only using it for project, then you can keep it in project as well. So I have shifted it to edited in user legend and then close. Now I'll use zinc column, and now I have 2 legends, one in the project and also in the user. I can use any of it because the color are same. I'll use a user right now and we'll see what is the color range. So it is perfect what I wanted. If you want to keep it in a display, you can drag it and keep it somewhere outside this window so that it will remain there for some time to have a look when you're correlating. So apply it. Now it is applied. Now if you see along the download, the legend color is just falling at the column of the lithology or the column where there will be lithology codes. So it may happen that you may not be seeing the lithological code if the graph is getting directly overlaid. So you want a gap between them. So what you can do is you can go to the width and margins because it is at the right margin. So go to the right margin and keep, say, for example, keep it 0.1. So you are creating a gap here, which will be visible when you will apply it here. So I think I have to make it a little bit more, make it 1. Okay, I make it in wrong direction. So it should be in the left margin because it is falling at the left margin, right? So there is a left margin also. Now you also want to display lead because you are going to correlate on the lead and zinc basis, not only on the zinc, because lead is also important and economic. So you are going to correlate on the basis of TMC, total metal content, which is zinc plus lead. So you have to populate zinc as well. So what you can do, you can create another insert and select lead. Same graph color, histogram. I'm going to keep the same graph, and I'm going to create another legend for this as well. Or otherwise, what we can do, we can this default legend also we can recreate it. Say I don't want to disturb the project file, so I'll copy it to the user legend, and then I'll edit it, rename it here. And then I'll change it. So for example, I want now the lead values lead values doesn't go much high up. It generally goes only up to, there are 46, 47 values, which is shown here, but generally the cutoff for lead falls somewhere around 0.5 or 1% because the lead values are that much economic at those levels also. Overall, what we do for this model or for lead and zinc, when there is lead and zinc in combined, the total metal content cutoff is generally capped at 3% or 2%. For this place, that is capped at 2%, but it generally is capped at 3% lead plus zinc. So that means 2% of zinc and 1% of lead combines to 3%. So for this purpose, we can keep a cutoff of 0.5 and see how this is behaving and can create a model. So 0.5 we can keep at below as a below range, then 0.5 to 1, and then I don't require so much, so 1 to 2 is fine, and I'll delete remaining. Click delete and it will get deleted. 1, 2 is fine. Then let's say 2 to 3, and then 3 to 5 and greater than 5. Okay, so that's edited lead. Close, go down and select edited lead. Now there is another thing in the legend file. If you want to copy it and you want to import it in any other legend file, that also you can do. You can right click the legend and you can go to save legend. So it will get saved in one of your folder as .elg file. And now you want to import a legend, so then again right click on the user legend and then you can load a legend and select the ELG file. It will get loaded in your new project file. So that way also you can use. बोर तो नहीं हो रहे हो?
नहीं sir.
No, sir.
Okay, so that is done. Edited legend is done, and then I am selecting the edited whole file. And similar process to have a gap in the width. Here I will do it in the right margin, which is right. So that is done. Okay, apply. So there is a gap. Now, after this, these are other additional inputs, which I also don't know. But what I know is this template. So this is very useful tool. What you can do here is you can create drill hole template. Like for example, you have done so much activity, like you have created an level the borehole ID at the bottom with a distance. Then you have also colored the legend with geology, and then also inserted columns of lead and zinc. But you want to preserve it while when you create another whole file, you want to apply the same process or same items or properties in your new drill hole file. So you can save them. How? You can go to the template and create a new template and name it, say, drill hole. Then select the drill hole and click update template. So what will happen? It will update the template with the current properties which has been used. Now if I close it, I click apply and OK. I've saved it. So I'll now unload it. So if you see here right now, you can see all the properties have been applied and it's showing nicely. OK. Now let us unload this. You can click here also in the loaded data to unload the drilling data. You can unload it. Now I'm loading the drilling data again. Drag and drop. So the property has been gone. Properties, all the property are gone. Now if I want to again format it, I'll simply go to the template, select the template and apply template and apply. So all the formatting which we have done will come up again. Okay. So you don't have to do it every time. You can save the template. Now, for example, you have done this template in this project, but you have, for some reason, your project got corrupted and you are creating a new project. And then again, you have to do the templating or you have to again do the process. So there is another solution for that also. You can go to the template, click the template, and you can save the template by exporting it. Sorry. By exporting it. So the extension for template is TPL.3D TPL drill hole template. So you can select the location where you want to save it. Say you are saving it in the same location, save it. OK. Now, if you want to import it, you can import the template from going here. And the template will get imported and you can apply the template again in another project. OK. Now, another thing is, say, for this particular project, in all the drill hole file, every time you want, whenever you are loading the drill hole file, you want to get that template used. You don't want to apply, go back again and forth and apply those drill hole template by selecting the template. Then what you can do, you can make the default template as drill hole template, apply, OK. Now, if you unload it, and then if you load it again, it will automatically come up with that template only. Okay. Clear? Any question in this? Or if you have any query or any problem which you have faced while using some of the things which you think, is there any easy solution for that? So you can ask now regarding this templating or formatting.
So,
No questions? I'm audible now clearly to all now?
Yes, sir.
yes, sir.
Yeah, Shiny. Shiny, it is clear?
Yeah, 1 minute, sir. 1 minute, 1 minute. Sir, I have a doubt.
You
Yeah,
just created
tell me.
two different legends na, for zinc and PD.
Yes.
Why it is showing only zinc here?
Is it? Let's see. Check. Let's check. Go to the
No,
horizontal
I'm
plane.
just asking. It can't be together like a zinc and PD.
Then you have to create an additional column which you have to create in the original file and then add zinc and lead together. Then only you can display, because it is displaying whatever there in the input file. So the input file doesn't have right now any column for zinc plus lead.
Okay, sir. Okay, sir.
So if you create another column which is having zinc plus lead, then you can reflect that in that particular format. So that is also possible. So for that, what you have to do is you have to go to that whole file, double click it. And here in this editor, you can say you want to create a column for lead plus zinc. Okay, PB and zinc. So you can insert another field here. Oh, sorry, it has inserted in the wrong place. So after zinc, I want to insert. So let's say I am inserting one field here. Let us call it as TMC, total metal content. Now what I want it should be populated with lead plus zinc, right? So it will be a numerical field. Default, I will not put any default field. I will go to the formula and here I'll type PB, double click, plus zinc, double click. Okay, and test it. So it is saying failed to add column BHID to formula praiser variable already defined BHID. Okay. What happened? Yeah.
But sir, at a time, both legend cannot be applied on that same borehole, na? Like
Yeah, both
you have.
legend can be applied. So lead will be displayed in a separate graph. Zinc will be displayed upwards, and there will be geology that I'll show you. But if you want to apply both together, that also you have to.
Okay, then we have to create a new column with together with lead and zinc.
Yeah, so that column is created. You are
Okay,
just
then
putting it a formula here. I think it will be like this. No.
then sir, after inserting that column, then we need to create another legend, right?
Yes, you have to create another legend then.
Okay.
I don't know why it is not creating. I think there is some error in the this not an error, but I think it has to be in inverted commas, I guess. So I don't know. Or otherwise you can go directly to the Excel and add it, but it is possible here also. I have to do some trial and error, but it is possible here. You can add. So let's not do this right now. I'll show it later on.
Okay.
So for example, this is one method. Another method is you can go and run a command called extra and add a column. That also will do. Now let us see whatever we have plotted. Let us see that first, and then I'll go to that question. Now this is in 3D view, right? Now you want to see it in a, say you want to see it in a section or in a plan view. So to see it in a plan view, you have to click one on the command, clicking on the window, and then you have to press one in the keypad. Or otherwise, there is another option of going to plane by one point is in the toolbar in the right hand side, define section about single point. Click this and then click. So it will ask horizontal, north, south, or east, west. If you want a horizontal section, click OK, and then go to view and then align it. So this is your horizontal view. Now you want to draw a section along, say you want to draw a section in the middle along this side from left to right. So go here in the toolbar, click 2 by 2 points, or in the keypad also you can click 2, then click here. So clicking should be left click right now, left click. And so this is draw. I want in this section, say, so click 2, then left click, vertical section, OK, and then align. So the section is aligned. Now clipping is not used right now. So in the menu bar in 3D view section, you can clip it outside. So this is and the width here selected is 10. So we will increase the width. Say we increase it to 25. It's not fully visible right now. So maybe we increase it to 50. It's not visible yet. Let's see. Let's make it to 100. Okay, now it is visible. Now, whatever we have plotted, it is not getting visible, the legend of the graph, right? This column. Why? Because you have been using a cylinder curve. So remove the cylinder and use pixel, apply, and reduce it to say 2, apply. Okay, now if I zoom in, now say for zoom in, zoom out, you can use your scroll bar also. If you scroll towards the screen, so you will zoom in, and if you scroll out away from your screen, then you will be zooming out. Other command is by clicking on the window screen, if you click ZX, so zoom. Now when I click ZX, see at the status bar at the bottom corner, bottom right corner, ZX zoom graphics. So this is the short command, and if you select the area which you want to zoom, so now you can see the zinc is plotted at the downside and lead is plotted at the upside, and the column is considering having the geology. So if you see, the GMS is having the gray geology is mainly having the host rock, mainly having the ore values.
Sir, can you apply both the legend again?
Both the legend again in the column.
On the drill hole.
So you have to go there in drill hole properties, go to the column and insert, and you have to select the legend. Select the column which you want to put up as a legend, and then you have to go to the graph color, field histogram, and you have to make the legend for that. You can select that particular legend with that particular hole file, and then you can apply it. And once applied, that will get reflected here. And also, because I have applied too many, so it is showing I can remove one.
Okay.
Yeah. So once it is applied, you can double click back again to set it properly so that you can see the geology as well as the legend file. So for that, I have kept a width margin of 1 in the right hand side for the lead and in the left hand side for the zinc. So if I apply it now again, so it will get reflected. Okay, and the color and the download file is colored through this method, through this lines and symbols. If you see, download has been colored with lithology with this legend. So that's why the legend is displayed on the geology legend is displayed in the download, and the graphs are showing the grade values.
Okay.
Clear?
Yes, sir.
Now let us check if I can increase the thickness a little bit.
Yes.
If I now make a cylinder and reduce the size.
Sir, this legend has not applied on the borehole. It's coming outside of the borehole. Like, yeah, proportion
Where?
of that lead and zinc.
Which legend? Yeah.
Both proportion is coming. Like, how many percentage is come in the intersection?
So this is the graph, now. You have applied. We have applied for example, for lead. Let us check for this lead. So lead is coming like this now. For yellow is what? 2 to 3%. Red is greater than 5%. 3.5. So this is the variation in the samples that is reflecting here. 1 meter sample. And this is geology. So geological, what is the legend for geology? Geology legend was this.
Litho.
Litho. So GMS is colored as gray. So this is GMS. Look, this is GMS. And rest is green. So GBG and these nices are there at the walls.
Okay, then at the same time, we have here applied 3 legend on the borehole.
Yes.
On geology,
Sorry.
then lead and
Yeah.
zinc percentage.
Yes.
Okay.
Because when you will be correlating, these 3 things will be required to correlate. Say you have a cutoff of 2% for zinc. So I have applied so many colors, but you have to make it a little bit simpler while correlating. So what you all have to do is you have to go back to the legend and you have to make a simple legend for analysis. Say if I'm saying zinc to be greater than 2% and less than 2%. So let us create another legend in edited zinc. Let us copy to user legend again and copy, use this edited version. Let us make it to edited zinc. And here I'll use only 2 colors, one less than 2 and rest I'll delete, and the red as greater than 2 for zinc. Okay.
Okay.
So, and I'll apply that here. So I have less than 2 as blue and greater than 2 as red. Apply. One is done. Same I'll do for lead. So I'll go again and copy it again. And I'll change the edited legend to 2. And here I'll make less than 0.5 and greater than 0.5, right? So I'll remove everything. And I'll not make it red. Let us make it pink so that there is some difference to understand what is lead and what is zinc. So greater than, anything greater than, wait. .5 will get reflected as cutoffs for correlation. Okay, So that is done. Apply. So now you can see the cutoff, how the cutoff is behaving. So in that case, if you see right now here, this is my geology, GMS, right? But there is
On the
some
board.
sample which is going in the another rock type, which is having more grade greater than cutoff.
20%.
But the lead is clearly demarcating within the lithology.
Lithology. Yes, sir.
But there are some samples which are falling outside the lithology for zinc. So that means either there is some geological error, because we have to consider what is the cutoff we are going to consider. Because when you are correlating any ore body, two things you have to keep in mind. One is the sample cutoff, whatever cutoff you are considering cutoff grade, you have to correlate on that basis. But also you have to consider that lithologies are not getting overlap. You can't combine two type of lithologies in one. So that also you have to consider that the host package should be, if it is GMS hosting the rock, hosting the mineralization, so the adjoining mineralization which is in some other rock type, that needs to be segregated out. At some places or sometime it is not possible, then you have to do some indicator kriging and separate those geologies for estimations. But wherever, as we are mentioning here, that all GMS is having the host rock, so you have to consider it accordingly and do the cutoff properly and create the strings for the ore body generation. Okay,
Yes,
am I
sir.
clear?
Yes, sir.
Now this is the section. Say for example, this is a cross section where there are so many drill holes and you are going to correlate the ore body. Now let us have an exercise. For example, if you see here also, there is a separate lead zone and this is the separate zinc zone, right? So if you go through the sections, how you can go through the sections now? Let us have a feel of the data sets by going through and moving around along the cross sections and all. So this is one section.
Yes, sir.
If I zoom it, now I want to move through the section. Say I want to move 50 meters north and 50 meters south to each of the section to see how it is behaving. So I'll go first, I'll go again, click one and go again to the horizontal view to understand the section distance. And now for this, what we are using for clipping and non-clip undo clipping, there is a short command for using clipping, which is UC. If you click one time UC, clipping will be closed. If you click again UC, the clipping will be applied, and the clipping distance will depend whatever clipping distance you have considered earlier. And this clipping distance you can use from here also in this toolbar in the right hand side. There is this called, there's see clip outside and unclip. And then if you want to clip only at the front side, you can clip the front way. And if you want to clip the back reverse, you can do that as well.
Okay.
Now we have removed the clipping. Now, if you see the section distribution, let us first apply the gridding properly. Now, if you go here in the sheet area, you will see there is a grid folder which is showing a default grid. You can double click the default grid and you can apply the grid distance here at fixed intervals, say X 100 interval, or maybe you want to do it in, let's say, every 25-meter interval. So you can do that also. Apply. Okay. Now the grids are at every 25-meter interval. Now, if you see right now, you can get a proper idea of how the samples are behaving at what section interval they are like now. For example, if you see here by zooming in, there is this is a one section line where there is drill holes. Then there is this section line after 50 meters, because each grid box is right now 25 by 25. So after two boxes, that means 50 meters, there is another section line. And this is one hole 11 number which has deviated from this side to this direction. Okay, so there is no section line for this, but yes, there is one hole which has been drilled at some lower level, maybe at underground level, in this section also, which is almost correlating with this deviated hole. So accordingly, you have to decide what are the section lines you want to consider. Say I'm right now seeing that every 50-meter interval, I can consider some sections. Right. If you go forward, you can see at every 50-meter interval, you can consider some section lines. So every 50-meter interval, you can draw some section lines. So
Yes, sir,
for
but
that, yeah.
sometimes what happens is there is some drill holes within that 50-meter interval, na?
Hmm.
At that case, what should be done?
For example, here also there is some holes which is within 50-meter interval, right?
Yes, sir, 25-meter interval.
Yeah. So there are two options. One, for those areas, you can create subsections within between those two sections and create another subsection line and draw correlate. Or when you are using 50-meter section line, obviously, when you are using 50-meter section line, what will be the clipping width you will be keeping? Clipping width means this side how much width you will keep and this side how much you will keep. So that generally depends on half of the section distance. So when we are talking that we are saying that we are going to keep section line at every 50-meter, that means our section width or clipping width is going to be half of 50-meter, which is 25-meter. So if my section line is this, say if I draw a section line here, if this is my section line, then 25-meter to this downwards and 25-meter upwards will be my section width. So that means my complete section horizon is becoming this complete area, right? So if my section line is here at the center, I am covering with the section width, I'm covering complete this area. So this is the complete area where all my drill holes, whichever is there, is coming into my correlation window, and I'm going to correlate that. So what is happening for the next section line? What is happening for next section line? This is becoming my section line at the center. And what will be my section width in that case? It is becoming this as a section width. So there is no overlapping, right? So if you are considering 50 meters, so the hole which was at the center that is falling will fall either of the two sections, it will fall where you can correlate. Got my point? Now, how you are going to select a section line? So you are not going to select a section line. You have to remember this. You are not going to select a section line on the basis of collar location. You have to select a section line on the basis of intersections, which you are going to correlate. Here we are going to correlate lead and zinc. So we have to see according to the survey line where they are falling. And that way you have to create sections. Because it may happen that the collar is at some other place and you're creating a section, but the actual drill hole intersection is in some other section. So that will create a problem while correlating. Because you have to use snapping and all. And that way it will create, while wireframing, it may create problem. So now let us understand how we are going to define the sections. So here what I did, I have drawn some lines, right? How I have drawn these lines? So I've used a command called ns in short key. When I click ns, you can see in the status bar at the bottom right, it is showing here ns new string.
So
This
shall
you
I
can
please-
also use. Yeah. So I used one command called ns just to define the section, not to define, but to visually see where the section lines are. I had drawn some lines, right? So I used command ns to draw those lines, and when I click ns in the keyboard, it gets reflected at the bottom right corner as new string. Okay.
Yes, sir.
And then when I click here, I can create as many lines like this using this ns and clicking clicking left click. When I right click means it gets snapped on that particular other point where it is there. So I'll show you the use of snapping and non-snapping when we'll correlate. So this is the about section defining sections. Now you can there is one way where you can create click ns and you can create section lines. So it will develop as a different section a file as section file, which you can use for later for correlations. So because that is getting stored as your defined sections, or you can directly create section line here using by 2 points and start correlating. But it is good if you save your section lines using this ns command and draw some sections. So we will draw some sections and we'll save them. Okay. So I'll click ns again, new string. When I click new string, you will see in the loaded data there is a file get created saying new string, and the same thing happens in sheet area also. In the folder string there is a new file called new strings. I'll name it first. So right click, data, save as, extended precision. Always select extended precision and then name it as, say, section definition. Not section definition, say it as section strings, section underscore st. So my section underscore st file is created. Now I will draw the section lines here and will save it. Now I want to preferably draw it at the top of the surface, not at any other place. So that to see if I am at the top of the place or not, I need to know what is my top RL and what is my bottom RL, right? So I can do that using a general command called stats. In the batch command, I can type stats, stats, enter, and here I'll take input as my whole file, and no need of any output file. Just go to the field tab, and in the field, let us select Z because I want to know the elevation. So only Z, then click OK. So in the command prompt, you will see the Z values, then click the green tick button. So it is finished. Now here you can see the maximum Z is 393.8 and minimum Z is minus 1257. So it has gone up to minus 1257 MRL, and at the maximum RL was it is having 393.8, which is somewhere, if you round it, 394. So 394, 395 MRL, you can keep your section line. So that we understood. Now let us go here and let us go to this cursor, mouse cursor location, which I showed you earlier, that you can lock, double click, and then you can lock the Z. Now, if you double click, the mouse position is open. Now click the lock in the Z and type here 395, for example. So Z is locked. Now click the cursor in some other area and then on the screen. Now go to plan view again. Click plan view, or by clicking here in the toolbar, or by clicking in the window, clicking in the keyboard as 1. So then you click anywhere, it will click at 395 RL because the Z is locked. XY may vary, but the Z is always, it is going to click at 395. Then horizontal, OK. Now if you unclick and free the Z from locking, and then you bring your cursor here in the window, you will see the Z is locked at Z in the cursor position. Z is now locked at 395. So whatever you create right now, the Z is going to be at Z. So now align it so that you are in perfect Z horizontal position. Now you go back to the section string and click. In keyboard, you type NS. Now, if you want to see if you are in the right section line or not, so section 5, when you click NS, you will see here at the bottom command bar, there is this string file which is selected, and the file in which you are currently saving is string st. So that is correct. The color is gray. If you want to change the color of the string file to any other color, you can do that. Let's say I want to make it more visible color, say magenta. I will use magenta so that I can see it more properly. So I'll use this 54 number. Okay. Now I know what I have to do. I have to check for the intersections and draw the section line. So first section line I want to create here, say for example. But I want to create a section line which should cover complete area. So I have zoomed it and see where I have to click the first line. So I did it, say I click it here. Then I'll zoom it out and straightway in that particular grid only, okay, you have to keep it straight. That particular grid only you created, say covering the complete area up to 1600. Let's say I am taking it up to 1500 easting. I clicked it here. So this is, now I have to click escape so that my string is complete. So this is my first section line string, which I have created. Okay. Now, for example, I'm seeing while zooming out, I can see that there are some areas which may fall outside. So I want better to keep little bit more. So what I can do, this is 0 easting. So that means this is 50 and this is 75, maybe somewhere more. If it is not visible, say for example, only major grids are visible right now, you can go back to default grid and uncheck the major lines and apply, then you will see all the grid values. So say I want to keep it up to -100, for example. So I'll click this and I want to move this point again. So moving a point is short command MPO, which is move point. Then I'll left click it and I'll take it to say 100. Escape. So this is my first section line which I have created. And if you now see in 3D view, it will be at 395 MRL because I have logged my level plan at 395. Okay, so this is my first section line which I have created. Now say I want to save it also as not only a section line, but also as a section definition file. Now, for example, this is my first section and this is a string file. I don't know if it will consider as 1 or 2. I want to keep a column which will properly identify my section line. So there is a command for selecting string. There is a command to edit the attribute of a string, EAT, short command, edit attributes. Now here you can see there is line style, symbol, color, and block ID. Nothing else. Maybe in the block ID you select it and name it as one. So this becomes your first section. Apply. Okay. Now in your string file, if you save it, this is all right now in the loaded only, but because you saved it, there is a folder created called string file where you can see your section string. If you double click, you will see XP, YP, ZP, which are the XYZ coordinate of the string file. PTN, P value. What is PTN, P value? PTN is, you will see PTN will change and P value is constant because P value is for, it will be a single number for each of the strings. So because there is only one string, so there is only one P value. But because in that P value, in that string, there is multiple
Sir,
इतनी शांति क्यों है भाई?
Is it visible screen?
no, sir, your screen is not visible.
Okay, let me. So I've shared, but it is taking some time. And up to how much you have seen, where I got disconnected.
Sir, that edit the attributes.
Okay.
Sir, I have one question.
For
Yes.
this area, we have chosen the ZRL of 395. So, sir, what are the criterias for choosing this fixing of the Z collar, and why do we need to like fix this particular Z collar for creating section lines?
It's just for the visual effect. So if you have not fixed it, say right now I have fixed it at 395, considering that everything is below 395, right?
Mhm.
So if I don't fix it at 395, then what will happen? Wherever my level plan will be, the section line will be shown, will get reflected in that particular level. And it may be at the in between the sections, or it may come at very bottom level, or it may come in any place. So there will
Yes,
not
sir.
be any consistency in the section line. First, second, generally when you are displaying a section line, it is better to see a section line where the section line is displayed at the top of a section above the topography. So that is main reason why we try to keep it at the same level. And it will later on also help, because if you want to create section boxes to actually evaluate resources or tonnages for each section line, then it will be easy to define the section line if it is at a constant level.
Okay. Okay, sir. Okay.
So it's just a ease of use. There is no fixed thumb rule, but this is an ease of using of section line.
Okay.
Okay, is it visible now, screen?
Yes,
No,
sir. Yes, sir,
visible?
it is
Okay.
visible. Yes, sir.
Okay, now let's go and again into edit attributes. So what I did is I selected this string and clicked EAT, and I have added one in the block ID. I have added column a number called 1, representing my first section line, and then applied OK. If I save it here in the loaded data and see it in the project window again by double clicking, I can see that other than XP, YP, ZP, it is showing my block ID as 1. Now there are 2 points, which is PTN and P value. So what is PTN and P value? For any section, any string file, you will see a PTN and P value. P value is representing each string. Each string will have a unique P value. And for that unique P value, each of the points which are creating, which is making that string, those will be represented by PTN as 1, 2, 3, 4, how many, depending on how many points are there. And each PTN value will have their X, Y, and Z values. So that is how it is defined. The string file is defined. And in string file, the header will be always XP, YP, ZP for coordinates. Whereas in point file, it is represented as XPT, YPT, and ZPT. So my first string, I have created the first section line as per in here. Simultaneously, what I'll do is I'll keep on creating some section definition file as well, which is a different thing. So let us first go to plan view. So what I did, went to in the plan view, I created by 2 points and drawn a section line. That's why it is looking like this. And now I will align it to the section line. Yeah. So now you can see the string is at the top. Now I'm seeing every file, so I have to use clipping. So I can go from the menu bar also, or I can in the toolbar as well. I can click this, and I will be at the clipping window of 100 meter. Now I want a clipping window of how much?
25.
Clipping window of 25. That means width of how much?
50.
50. Because I'm at every 50 meter interval, I'm creating section. So I have to change it to 50. So now this is my first section line, okay, which is 1. Now, for example, I want to save this section file also as a section definition file. So there is a command. Let me check if it is in use now. Yeah. The short command is SVI. in keyboard, which is save view. Now in save view, you can give either you can generate a name. It will define, like it has automatically generated section 703.55. The reason being the easting value was around 703.55. That's why. So that way you can keep it as that way also, or maybe you can keep a default one name as say S1. This is your first section, so S1. And these are the parameters of section definition. So this is going to be the window of extent up to which the section reference distance will be used. And this is the width. If you click this, then it will become infinite. Right now it is at 2525, which is 50 meter, which is fine. Then click OK. So you will see there is another file which is created in the loaded data as section definition. This is also, I think this also creates in the sheet file also. I don't know where, but it gets created somewhere. Yeah, in section folder, if you see default section S1, it has got created. Now I can save the section definition file also. Right click, data, save as, extended precision, section same name, save. So section definition file is saved. Now this is the file name of the section definition, where there is one section right now, which is S1. Okay, that way you can keep saving your sections. So you don't need to go direct every time to plan view and cut the section and can come back again into your section definition. So you can create a section definition file and keep the sections as it is. Now it is done.
Later, like if you want to change the width from 50 to 80 or 60, so whether this will change the section definition or it will be fixed to 50 only?
It is fixed to 50. If you want to change, you have to go to the section definition and you can change it here, front and back. Then it will get updated.
Okay. We cannot change from that with upper column. Okay, sir.
No, here you can change it. No, you can't change it from here. You may try. Let me check. So for that, first we have to, let's say, save it and remove it. And I want to use the section definition file. Okay. So let's go and check.
Using that entire screen sharing mode or another screen sharing mode?
Another right now.
Yes, sir.
You are sure?
Because
I'm sharing only one screen.
Datamine screen. The
Datamine screen, no?
Yeah, yes, the subscreens which come on clicking that we are not able to see.
Okay, so there are two screens. That's why you are not able to see. Okay, I'll take care of that. Now let's say in section definition, I saved it as a section definition file. Let us remove it. Unload. Okay. Now I loaded the section definition again, like this. Now I want to go to my, like, see, you can see the section definition file with the red boundary with the section limit. So now, for example, I want to go to that section definition to, so the command is gvi get view, but it is only supported in, okay, so I can go directly. So I have to go here and yeah, maybe I can use this and let's see. Yeah, so this is a section definition file. How to go to the section definition. So let's for timing, let's do this only. I don't remember right now. So let's go to the section and align it. But there is a command, I'll tell you. So now, say for example, I have gone to that section definition and I want to use it. You see, and I want to apply it. No, I can't able to make it apply. Because GVI is not working. So GVI, if I don't use GVI, so how can I plot it? Okay, I can't show you right now because I don't know how to get. If anyone knows in or can find it where from this menu bar we can display the section window, but then do tell me also, because the logic is you have to get it into the section definition file. For example, if I do it in design window, let's try it in design window. So in design window, so this is your file. Here you can get GVI. So you will see in the command prompt is asking which section you want. So there's only one section, which is one. So I'll click one. So it will show you that particular section with that particular extent only. So if you want to zoom it, you can do it and correlate it, but the clipping width will remain as it is. Now, if I want to update it here, sorry, I can't tell you right now because I couldn't find it how you can do it here. No, I can't. But yes, you can change the clipping width. That is possible. That is not a problem. In the section definition, you can go double click and change the clipping width, and accordingly it will get updated. So main objective of this is to save the section definition files so that later on when you come back to your correlation, then you can do it. So here, let us finish the first creating section definition files. So we are at 3D window, right? Now I want to go to the plan view, but I want to go to the plan view at 395 because I was creating the sections at 395. So we'll go in the Z again and lock it at 395. One horizontal, align. Okay. So, and then I'll load my first section definition string, which is this one. Now, where is the next? So I want to create it at -550, right? So let us create it at -550 in this. So again, NS will just cross verify that the string file is selected correctly and the color code is correct. Then I'll use it from the same extent. And keep it up to this. Escape. Escape. So this is done. Then again, I'll select this EAT, change that block ID to 2 so that I can keep on continue saving my section line also. Now, if I want to save this section definition again in section definition file as well, I'll drop the section. I'll do that, but we'll check how best we can use it. Right now, I'm facing some problem in viewing it back, but I'll still keep it saved. So I'll go to that section again, click the section line by 2 points, align. use the clipping of 50. So 50 clipping is used. And I want to save this much as a section definition. So I'll save it as VI and save it as S2. Sorry, it got saved in some other file. No, I want to save it here. Yeah, it got saved. So if you see in the sheet, there is S1, then there is another section which is S2. Okay, which is having again 25, 25 when S2 is generated. So that is done. Now again, I'll go back one plan view, but before clicking plan view, I will. Okay. Again, I'll go. Save the section definition file. And then again, go to the plan view, Z, fix the 395. So let us do one thing. Otherwise, let us draw the section lines first. That will be more quick. And then we will draw the section definition by 1 point. Okay. So right now we are at 395. Yes. So I'll remove the section definition file for now. And I'll keep on drawing the section strings first. So that's my another section. EAT 3, apply, then NS. Four, five, six, seven, eight, nine, 10. $11. Okay. So 11 sections I've drawn right now. So we'll see how we are going to correlate here. Then we'll talk on these, or that will be an exercise. So these 11 sections, I'll save it. Now I'll go one to one each area. Shit. See what happened. I could put it at 395, but it didn't happen. Didn't create it in 395. Now what we can do? Say if this problem comes up, you wanted to create it at certain level, but it didn't create it at that level. So what you can do? Whosoever has used Datamine earlier, what is the command that you can use? So what you can do is, there's a command called TRA, which is translate string. You can translate it to a particular Z. Now for that, you have to know what is the Z level. What is the Z level of this? So for this, either you can do a query, which is this, because this is a string. So you can select this string, any string, because all strings are at the same level, and do a query by using short command QST. Now, when you use a QST string, query string, that gives you some details about the string file, which is X coordinate, Y coordinates of those file. And also, so within this coordinate, you can see the Z coordinate, which is -430, as well as length of the string and horizontal distance. And these things are also there. So from this, if we see Z is 430.5 minus 430.5169, and we wanted it in. So can you see my calculator here? So is it visible now? Calculator is visible. Yeah.
Yes.
So if you go to say, I wanted it in 319. So 319 plus, because it's in minus MRL. So 319 plus 430.1175. So this is 7491175. Okay, 7491175. So if I do a TRA, yeah, up to let us see, yeah, up to this file. So we have to do TRA, select for all files TRA, and the value is 7491175. Z translate Z by 74911. Sorry, 749.1175. Still it is left. So what is the RL then? QST. This is 395, and this is still at 318. So another, I must have done some mistake. Okay, 319. I have added 319 shit. I think भूख लगी है सबको, मुझे भी भूख लगी है, इसीलिए नहीं हो रहा, गलत हो रहा है. 395 प्लस, और सब ये से बोले जा रहे हो. QST 395 plus Z is 430.5169, which is 825.5169. Eight to 5.5.69. Okay. ठीक है, ये section lines बन गए. Let us have a lunch. Let us take a break, 1 hour break, and then we'll get back. ठीक है. So I'm saving the sections here.
Okay, sir.
So we can join after 1 year, na? 1 hour. Rather keeping it everything online. ठीक है. We'll join back at now it is 15. So ठीक है. We will join at 4 बजे, 16 o'clock, 1600 hours. ठीक है.
Yes, sir. 4 o'clock is okay.
Yeah. Okay.
Okay, sir.